The following message is best viewed on an oscilloscope.
I think we're making progress in the world of commercial particle physics. That was great. So, Miro, shall I start off and then I'll let you introduce talks for the first half?
Yes, please start off.
Okay, welcome everybody to cyberspace. I wish we were all in Prague. It looks like this. There's the tower. It's a fantastic clock tower. You can just watch that to see, to make sure that you're on time with your talks, okay? You'll each get 15 minutes to give your talk. It's fantastic to be here. I wish that we could all be together to have drinks together. Wonderful beer in Prague. It doesn't look like we'll be able to do that, but we are going to have some time. Miro, we'll have time in between the two halves when we have a coffee break. We can stay online, I suppose.
Yes, and the session will be open 1 hour after all the talks, so we can talk more.
Okay, so there's our informal coffee break, or actually later this evening it can be a beer break if you like, and we can sit around and chat as we would normally at the end of a conference. There was some complaints for the first cyber conferences that were done in particle physics that there wasn't enough time for the usual relaxed chatting that you get at a conference. So stick around. I'll have my coffee with you. You can't see it because of that image there. Okay, during the break. And I'm not going to take up any more time because it's my time. I believe that I'm going to be our first speaker, and I've already used up a few minutes. So let me open up. Let me do my sharing. This was by
Well,
yeah?
Steve, before you start to talk,
okay, sure.
Let me say a few technical points, and of course, welcome on behalf of all organizers in Prague. If anybody don't know Zoom, please ask in chat on anything. We are a small group, but anyway, maybe please use the raise hand button if you want to ask questions. You can see it probably only after you click on participants. It's only one place I found this button. And don't forget to lower the hand after you ask questions. And yes, please stick to the time, 15 plus 5 minutes. I will probably interrupt by saying 5 minutes left or something, or I can type on screen. For the chat, jokes here, any serious discussion, please, on Mattermost. On the beginning of the chat here, there is a link, or you can find it in Dico. So please don't hesitate to ask anything, have a fruitful discussion, and Steve has news from IPOC as a first talk. Thanks.
Okay, very good. Let me see. Are you seeing my slides yet? Is always the beginning of every talk in Zoom starts with that. Okay, I'll put it into full screen. Does that work for everybody? Is it full screen?
Yes, it does.
Confirm. Excellent. Okay, let me get started. I'm going to give you an overview talk because it seems like the first several talks that we're going to have this morning, afternoon, evening, depending on where you are going to be on IPOG. I happen to co-chair this with my colleague Pedro Abreu, who's joined us. so he can correct any mistakes I make. I hope he will. This is just an overview of what we are, because I think it'd be good to have some background before you learn some of the details from Uta and Nicolas when I'm done. So just to get started, I wanted to remind you, I know we all went into science to avoid these people. This is the general public. You know, they scare us as scientists, but actually they're pretty good people, and they fund us. They look like this. Actually, now they look like this. They've gone over a slight change recently. But these are good people, but they have a lot of questions. They do a lot of hard work. As you can see, they have a variety of different jobs. They save up their money to be able to eat and to have a home and to take care of their children. And they ask themselves this question: why should they take some of that money and give it to us to do fundamental research? What's the point of that? Here's a slightly lower life form. We call them politicians. They're also very important people. They try to run our countries. You just have to speak a little more simply to them than the others. They have a lot of questions themselves, and they're all over the globe, and they have a lot of worries, a lot of concerns. They're trying to run their countries, and one of them is what to do with the resources that their country has or wishes that it had. And so hopefully they're asking this question, which is how much of these precious resources, which they need to build the infrastructure for their countries, should they put into fundamental research? I hope they're just asking how much and not whether or not. Here is a higher life form. These are the people coming after us. This is the next generation. These are students. These are the most important people on our planet, in my opinion. They also have a lot of concerns. They're studying, they're trying to learn, they're trying to see what they can do to make the world better, fix some of the mistakes that we made. And they ask themselves a couple questions here, which are rather important. Who should they believe? And what should they do with their lives? They have a whole life ahead of them. They see a lot of different answers when they look out to the stars, or even worse, if they look out into cyberspace. They see a lot of stuff. Some of this stuff doesn't really give them the answers that they should have. And there's a lot of stuff out there, and I'm being very generous in calling it stuff. There's a lot of people saying different things which are not based on science, which just help to support their own agenda. And sometimes they try to hide this off as science. You know, a good example actually is this homeopathy journal. Okay, water is water. Most of us understand what water is, but that is, it's close to looking like a genuine journal of science that exists. And if you want to talk with me about that over coffee, we can afterwards. Regardless, there's a lot of stuff going on out there which is not the truth and which doesn't answer their questions. The kids are smarter than that. We have to give them a lot of credit. They know what stuff coming in from Twitter feeds is, accurate and what isn't for the most part. But if they do say, hey, I want to go out there and try to find some correct answers, they might go to something like YouTube and say, hey, let me learn about CERN. Well, here's a challenge for you. Log out of YouTube and then search for CERN. It's fortunate there are a few popularizers of science out there. Katie McAlpine at the beginning of the LHC, who made a rap that's still #1. And we just recently invited Physics Girl, thanks to the social media team, Loic over here at CERN. And we do have in the BBC who stopped by, but for the most part, there's a lot of crap up there. And a lot of people believe this stuff. It's a problem. In the middle of all of this environment of what people are seeing, we have a lot of big plans for our community, and they just got rolled out recently. We have plans, a variety of different ideas on where we should go next to look for physics beyond the standard model, to do precision measurements, to improve our ability to go beyond the standard model, to just look, as we always have, to build a bigger, better microscope and try to understand our fundamental components and what their interactions are, we have some great ideas, and they all make sense to us in our world. Yet we're going to be asking the public to fund these things, and that's not an easy job. I'm not going to go into details here, but this is the 70-year plan that's been brought out recently by the European Strategy for Particle Physics Update. How do we prepare to bridge this gap? Well, education, outreach, and communication. And that's why you guys are all here in this session. You know it's the most fundamental component of research, making sure that the world understands what we're doing and that they understand why this is important for us. Communication is essential. It's an obligation. We have to report our goals and results to the public because they funded it. We need to extend that reach continually through a variety of different networks using whatever media are out there to get the communication out. This is what we plan to do. This is what we've done. This is what we've accomplished because, again, we're using other people's resources. Education and outreach, in my opinion, of course, I'm quite biased, but in my opinion, goes a little bit deeper than that. It's got deeper roots, and that we're trying to go further than just communicate the results, but we're trying to establish a deep understanding of the scientific process and get students to get an appreciation of what is research, to build trust with communities, and to train the next generation, to get them excited. These kids, they're born scientists. We want to keep that interest. So in my opinion, and this is what we communicated to the European strategy, education, outreach, and communication are strategic pillars of research. They're what you have to do before we build. We've been doing the work to prepare the world to build a big ring, which is actually out there out my window. I'm not really in Prague. But you know, we have a lot of work to do. IPOG is International Particle Physics Outreach Group. We're an international scientific collaboration. We're not building on one experiment, but we are trying to optimize our usage of resources and our ability to do education and outreach around the world. We're a mix of researchers, people who are active right now in research and physics research, particle physics research, and people who are experts in communication education. We meet a couple times a year and we exchange ideas and we learn from each other. It's a global network that is continually growing. We are currently 33 members, so that's 26 countries. Countries are our primary members. There's also experiments and CERN as an international laboratory. We also recently added an associate member. It's a national lab, but in order to maintain one country with one vote on our collaboration board, they are an observer, but they are a long time standing member. They have been with us since the beginning, Daisy, and we're very glad to have them back now officially. These are connected, all of these connect us to networks around the globe, national networks and networks within the experiments. And we organize global activities, which you're going to learn about. I'm not going to go into details there because we're going to learn from Uta and Nicolas about these International Particle Physics Masterclasses and Global Cosmics. And we support local activities, so things which are going on. For example, at ICHEP, there's going to be a public event, and we're going to be heavily involved in that. Just very quickly on the origins, because I'm aware that I'm going to run out of time. You know, IPOG was actually formed as EPOG, the European Particle Physics Outreach Group. It was Chris Llewellyn-Smith, who was the then Director General from CERN, who communicated that we have a moral obligation to inform the public of our activities, and we need to use our resources optimally. In 2011, we changed the name just to reflect the added membership from countries around the globe, not just Europe. This was in part because of the Large Hadron Collider, which embraced worldwide collaborations. And we formalized ourselves with a memo of understanding in 2016. This is thanks to many people working on this, but mainly Hans-Peter Beck, who was a co-chair with me before Pedro started this year for several years. And that was really his strong initiative there. Our goals are the sustainable development of particle physics outreach, to make discussion forums so we can improve how we do it ourselves, because everybody's doing outreach. IPOG are not just the people doing outreach. We're trying to support what all of you are doing. We're an exchange, an information exchange, and we're active working groups. We're trying to develop better methods around the globe. We're trying to improve our standards all the time. Every single time we meet, we come up with strategies to try to improve on the things that we're doing, the different practices, and to try to learn from others. We have long-term links because of this. Many of us have been in IPOG for some time, and that helps quite a bit. We try to develop more and more links, and we try to develop material. Is there something new that's coming about? There's new physics or perhaps new proposals for accelerators. We try to develop explanatory material for the public and for schools. Finally, we want to expand our global reach. We do this primarily through international masterclasses. You'll find out how far around the globe we reach with that, but also our own spectrum of the types of physics that we're doing. We're expanding in that direction, and also our own membership that is continually growing. Here you can get a view of our membership. You can see the countries which are in this sort of blue-violet that are our members. There's a few in green who were members before we formalized, but it's a rather tricky thing to formalize. It means you have to go to your ministers and get signatures. And so there's a few who we're still waiting for. And there's one that's Israel there. You can see Bulgaria and South Africa. Georgia just recently signed up, and I just have to go over there and get a signature for that. One of us will, Pedro or I will do that. There we go. What they sign up now, when I say we formalize, they sign up, and I think this is rather key, very important to all of us. The experiments agree to recognize outreach as a key component of the research program. And you'll see those words came into the strategy update, and that's very important. We are, you build hardware, you write software, you do analysis, and you do education and outreach and communication, okay? Same thing, it's all part of being a physicist. Experiments also have to recognize the efforts of their collaboration members, send them to conferences like this, and they also provide in-kind contributions like data, tools, educational material, in-kind support for doing the programs that we do. Countries give us a representative who can connect to their national networks, and often some modest monetary support at different levels depending on the abilities of the countries, much like a CERN collaboration. And then laboratories, well, CERN, we still rely heavily on CERN. They're providing us a lot of very important resources, and DAISY as well as providing us some coordination as well. So there's good, strong commitments, and we're now able to really commit to improving and growing. The organization you see as follows. You have both chairs here, so ask us whatever questions you want later on. Our core team include half of Barbara and half of Claudia. We're very happy to have that. That's been very, very helpful. Barbara's helping to really develop our new platforms, which includes a huge set of web pages and a resource database. And Claudia has been outstanding in holding our core together and getting us to stay organized with all the work that we're doing and to develop a variety of things. You are going to hear from Uta shortly. She coordinates masterclasses with Ken Cecir, who's in the US. And we have Global Cosmics Initiative, and you're going to hear more about that actually from Nicolas shortly. And we have a variety of advisory boards, committees, steering groups, and working groups, whatever you need to make things work. We share ideas in meetings. Twice a year we get together in meetings. The last time we were together physically was at CERN. And before that we were at GSI Fair earlier in 2019. Our most recent meeting, just like everybody else's meeting, just like this one, was on Zoom, was highly successful. We have snapshots of all of us. This is our group picture, it's slightly different. And we have a variety of different themes. We usually have a theme each time. When we were at CERN, it was on our expansion. So we heard from international relations at CERN, and we also heard from our colleagues at...
Sorry, Steve, time is running.
Okay, how much time do I have left?
5 minutes.
5 minutes? Okay.
I mean, for discussion mostly.
Okay. So I'll go through this quickly. Okay. Anyway, we've had a couple meetings. We talked about expansion, and then most recently, we had one where we had an important panel discussion, which is something we could perhaps talk about here, which is the importance of helping not just informal education, but formal education. I'm not going to detail here. There's links. You can find out more about us on these links. You'll learn more about Masterclasses shortly and Global Cosmic shortly. Other activities such as Worldwide Data Day, you can get information about that. It's one day where everybody has a chance to share data from the Large Hadron Collider and to analyze it. And we also have always helped out with CERN's Beamline for schools to help select and coach teams for projects for that. And finally, shameless publicity. We do a lot of work on public events and festivals, and most recently, so there will be a public event, which I think Connie advertised on Twitter, with the Big Bang stage. For the IPOG contribution, we have the Universal Science, which will be a discussion about the importance of diversity in science. And you're going to learn about recent activities about diversity and its help for science, as well as what our future plans are. This is targeted at the public, but we really want you guys to come and join us because the point is to interact with the public. So there's the shameless publicity. You can read about it there, universalscience.web.cern.ch. I don't have to show you this. It's just showing off that we're in the media all over the world, and we're at conferences, which obviously you know by now. So let me just conclude by showing you some future challenges which came from the European Particle Physics Strategy Update. I can let you read these. The most important parts here are that it was noted in this update, and a key point, that public engagement, education, and communication in particle physics should continue to be recognized as important components in the scientific activity and receive adequate support. So point your bosses at that, point your institutes at that when they ask why they should be supporting you doing your work. Its role could be further augmented to that of providing public engagement material. We recognize that, and that's why we're reaching out to these various events, various public events I mentioned. And finally, it should be seen as an integral part of being a scientist and properly valued in terms of career advancement. So any of you who are senior faculty, keep that in mind. Hire people who do education, outreach, and communication. So we accept these challenges, and we hope that you will as well. That's all I have to say. Thank you.
Thank you, Steve. All which is focused on students is awesome and fascinating. But as you started with hoax and false information, maybe older people should be also aimed.
Yes,
like
absolutely. But I put my hope in the kids. I put my hope in the kids.
Because grandmothers and grandparents teach kids.
Indeed, indeed. Should I take any questions?
I see no hands. Please do not hesitate. Argue with Steve.
Yeah, come on. I'll stop my sharing. There we go.
Hi, Steve.
Hey.
Hi, I was going to ask if there's another IPOG meeting for the autumn.
Yes, there is. We've already planned the date. It's early December. Do you remember the exact date, Pedro?
Hello, Steve. Hello, Kate. I think it's 3 to 5 September. 3 to 5 December. December 3 to 5 or something like that.
Yeah, we pushed it late because there's a great public event that's going to go on at CERN in November that a lot of people will be involved in. Okay. And anyone's invited to come. You can always attend one of our meetings.
Hello, this is Cecilia. Can you hear me?
Yes.
Hello, Steve. Can you please tell us, for example, I'm from Mexico, so if Mexico wants to join this, the group, the outreach, so is there a place where we can go to look for what are the requirements, to do it?
The best is for us to talk. That's the best thing. The requirements really are pretty simple and depend case by case. I mean, what we really need is that there's someone that can be dedicated as a representative, most important thing, and that you can get some commitment from whoever represents particle physics in Mexico. That could be a minister, a science minister, or it could be an institution. There's a lot of little details there. That's the hard part, is to make sure you find someone who's willing to commit in a very small amount of resources they have to be paid each year. But we should talk, because recently Hawk, the collaboration there, joined, and that was really our first astroparticle physics collaboration joining, and I think it makes a lot of sense for Mexico to join as well.
Oh, okay, thank you.
So please contact me, and let's make that happen.
Thank you.
Anybody else? I don't see hands. Okay.
Yes, or you can leave your question suggestion to Mattermost. Does it work for all? David, does it work now for you? Yeah, thank you, Steve, for now. Maybe we'll move on.
Yeah, Milas, it works.
Okay, good. So, Kenneth, are you ready?
So let's see.
I am ready. I assume Uta is ready also.
Ah, okay.
Uta is here and I'm ready, and I'm sharing our slides. So Ken and I are giving this
Together.
presentation together because we work together, and in this way it makes sense. So
I should apologize for not mentioning Ken's name. I didn't realize he was going to be here to give the talk. So.
No worries.
Okay. Looking for the correct window to share. Okay, just wait a minute. No, this does not work. Okay, then I have to share my screen. I cannot share the PDF. I don't know what happens, but
Yeah, it works.
now you see the PDF?
Yes.
So you should see the first slide. Okay. Yeah, so we'll give an overview about the current status of International Particle Physics Masterclasses. I'll start and then hand over to Ken right in the middle of the presentation. As we already heard from Steve, this is a program targeted to high school students, and the basic idea of the program is to let high school students work as much as possible like real scientists, so to make them particle physicists for a day. And in a masterclass, they can experience what it is being particle physicist for a day. This is like a masterclass in the arts, but in this case, high school students work with a particle physicist, and they work on authentic data from particle physics experiments. So the day usually starts with an introductory talk, and then they can have a visit or a guided tour if appropriate. And then they have this hands-on experience, which is shown in the image on the top right, where they analyze atlas data, looking at event displays. And they are invited by a nearby university or research lab to let them be scientists for one day. And at the end of the day, they have a video conference where they meet other groups from other countries, other research labs, and they can combine their results. All groups have analyzed different data, so this makes them feel like a virtual collaboration, and then can experience what it is being to work in a collaboration. So this program, International Masterclasses, is running in 60 countries, all marked green on the map at the bottom right. the countries in Europe are not named because there's too many of them. It's more than 200 research labs participating, and we have more than 10,000 students every year in this program, which runs every year in spring. These video conferences I mentioned, they run at CERN, they run at Fermilab, at KEK, at GSI, and at TRIUMPH, depending on the experiment where the data comes from, and also depending on the time zone where the people live in. And this program is organized by the great IPOC collaboration, and Ken and I, we are coordinating this program. So the program started in 2005. That was the World Year of Physics. And at that time, of course, students were working with data from the Large Electron-Positron Collider. Then we switched to LHC when the LHC started, and we had data. And today we have a variety of data and experiments that are available. There's not only LHC data since 2005, that's not correct, of course, since 2010, I would say. Then there's Minerva data since last year, and this year we started to include data from Bell too, and also a masterclass from particle therapy. And a brand new masterclass is from the dark side experiment situated at the Gran Sasso laboratory in Italy. And there's more under development, for example, a microboon masterclass. And today we'll present the current status of all these masterclasses. So one of the oldest masterclasses is dealing with Atlas data, and it's also one of the most popular masterclasses. So many institutes do this. There are two different measurements. One is called the W-path, the other one is the Z-path. And in the W-path, students analyze event displays. They look at, in pairs of two, they look at 50 event displays like the one shown in the bottom. And they have two tasks. First task is identify W bosons and look for the electric charge of the leptons, and then the resulting ratio of the charge is used to reveal the inner structure of the proton. And of course, these results from the student groups are compared to results from Atlas. And the second task for students is to identify W pairs and measure the azimuthal opening angle between the two leptons. And then they can build a histogram like the ones shown in the bottom, and they can compare it to Atlas. And this way they gain insight into the process of discovering the Higgs at CERN. Sorry. In the Atlas Z-path, students search for dilepton, diphoton, or 4-lepton events, and they build invariant mass plots. And then from these distributions, they can find resonance peaks from a known particle as the Z boson, the J psi, and the Upsilon. And they can also search for new particles. So they will find a Z prime, and they will also find a graviton. And from the 4-lepton and the diphoton, they get insight into the process of discovering the Higgs at CERN. So in all these slides, we have included the links to the relevant masterclass packages. In the CMS masterclass, students make use of a 3D event display, which is very nice for them. And they look for 1 di and 4-lepton events, so single lepton plus neutrino. This is a W boson. They also characterize Z bosons and Higgs candidates. And they create mass plots of standard model particles plus hints of the Higgs. And they can also determine the charge ratios and the ratio of electron and muon. And then there's a masterclass from LHCb. This is about the lifetime of the D0, and students search for decays of the D0 to K pi, and they perform a lifetime measurement. And a nice feature of this masterclass is that during the video conference, all the results of the students are merged live in a histogram, and they see the mass of the lifetime of the D0 coming up from this histogram. Then we have masterclasses from the ALICE experiments, and these exist in 2.5 flavors. There are two masterclasses that are regularly used in international masterclasses. This is the first one, looking for strange particles, where people look into the strangeness production, if it's different in proton-proton or lead-lead collisions. And the first part is a visual analysis of 15 events. And then the second part is calculation of numbers of the Ks, the lambdas and anti-lambdas from invariant mass distributions from different centrality regions in lead-lead collisions. And students can observe strangeness enhancement in this masterclass. Then there's a second masterclass, the nuclear modification factor masterclass, where students can look for quarks interacting strongly. And in the event display, they find the nuclear modification factor simply by counting of tracks. And then there's a route-based large-scale analysis where they look for various lead-lead centrality regions. And in this masterclass, students can discover the jet suppression. There's a new developed masterclass, a JPSI masterclass, where they students work on electron identification via specific energy loss in the Alice time projection chamber. And the workflow is such that students load charge particle tracks, they fill a PID histogram, they define selection and fill inverse mass histograms, and from that they can extract the yield. And this standalone app has been developed for all these 3 masterclasses, and it's easy to install, so you don't need root, but it works on Windows, on Linux in a virtual box machine. So now I hand over to Ken and give you the next slide.
Okay, so moving past LHC or to different regions, we've started to develop neutrino masterclasses. In particular, our first neutrino masterclass, as Uta mentioned before, starting in 2019, is based on the Minerva experiment at Fermilab. Basically, that's a experiment in which muon neutrinos interact with a carbon target, and students look at the resulting muon and proton tracks. They discover Fermi motion through their analysis, and they actually are able to measure an estimate, really, of the carbon nucleus, the radius of the carbon nucleus, to test their interaction model. And as they do a tweak on the interaction model, they see they get a somewhat better result. This URL is actually through Indico because it's on Fermi Indico, so I thought good idea to keep it as a Fermi thing, a Fermi Lab thing. We also have a microboon instrumentation masterclass in development, and I say instrumentation because basically it looks at how students measure argon purity and electron drift velocity from looking at tracks in the detector, and how long they take to go from initial interaction to hitting the photomultipliers. So we were hoping to have that ready this year. It got a little delayed, so we're hoping that in 2021 it will be ready. And we're just starting work now on a possible nova neutrino oscillation masterclass, and that's we're kind of excited about that, actually. Okay, so Bell 2 is another place where it really came to us from physicists working on that. So that's our first KEK experiment. And it's a very code oriented. If you're familiar at all with B-Lab, that KEK has been running a long time, mostly for Japanese high school students. Usually, I think it's about a 3 to 5 day, maybe longer process for the kids who come to KEK, and they do all kinds of stuff. So this is down to 1 day. Students use the visual code editor Blockly, which is sort of like a simplified way to code. And it's like a little bit like Scratch is what I was getting at. And so they are able to take the data, describe the case, make cuts, and then from that, from the plots they make, discover particles, at least at their level. It can run from a web or from the web or from a virtual machine. Yet they have 6 million clean reconstructed events that the students can actually dig into. So there's plenty of data. And when they're analyzing through software, that all works extremely well. And there's a basic and advanced level, and then the students have a video conference with KEK. That was sort of piloted a year before last, and then really brought forth this year, and it's been very successful so far. The particle therapy masterclass also started this year. That was put together by the folks at GSI, and that's also been very successful. So basically, what the students do is they look at images like the one you see at the bottom there, to look at look at actual I think simulated tumors, and figure out what a treatment plan might be. It is the most advanced in highlighting the benefits for society from particle physics technology, because, well, that's what it is. And there's been a very strong response in Latin America, which is very encouraging for us.
Kenneth, you have 3 minutes.
Okay. So future master classes. So we're going to be bringing Dark Side on very soon, we think, in 2021. So Francesca Kanaseki has been leading this charge. I won't say all the places she's from. You can read that. But it's basically dark matter experiment looking for WIMPs in the argon dual phase time projection chamber. Data analysis is by use of spreadsheets. So first there's reconstruction of particle position from a few events that they figure out how to exclude background. And then they do an analysis of many, many more events. And they're looking for those few rare, good WIMP candidates. And they did pilot in January 2020 with two remote events. Or rather, they had 2 remote events during the lockdown. Further neutrino master classes are also on the way. So we've discussed doing something with Opera, and we're excited about that. Our main goal is actually to eventually have a Dune master class. Of course, we want to have a Dune online for that. And so we're moving along, and we're open to other ideas too. Okay, and next slide. And yeah, so of course, we were hit hard as everyone else by the COVID-19 pandemic. So we suspended all of our video conferences by March 18th, and only about 25% of the master classes were completed. Our response has been, we've had 3 different phases we went through, or 3 things we did really. So one is the big analysis of muons and CMS. So we simplified the analysis, simplified it by limiting it to analysis of muon tracks, which are very easy to identify and measure for the students. And then we provided increased online support through screencasts. And then we got the teachers involved in sort of coaching the students. And it seemed to work fairly well. We had about 700 students participated in April and May. And a total of about 35,000 events were analyzed. Also, I'd say it brought in many students whom we might not have seen in these sort of traditional international master classes. So, for example, we had many groups from India, which and more than we ever had before from Chile. So we're actually quite excited about that. In addition, we've had small groups of undergraduates who said, we want to do this too, and they would get involved as well. Masterclass at home. So BAMC was led pretty much from Notre Dame, although of course, Uta and I work on all these things together. And then Masterclass at home was led pretty much in Germany. And that's where, but although some other countries did it, for example, Slovakia had their own way of doing it. And that's where the Masterclass is delivered online to groups of individual students. They have lectures and analysis. It's spread over 2 afternoons. And then students were able to, so they were using smaller groups of students, but really able to give them a lot of attention from physicists. And that worked very well. And we also had video conferences in the sort of a catch up for other groups that might have had their own master classes, but hadn't had a chance either remotely or in person, but hadn't had a chance to have a video conference. We didn't have very much turnout with that because for all the reasons one can imagine, so, but at least we were able to offer some folks that opportunity. Okay. So if you're interested, we'd love to get you involved. So first you may want to see if your institution participates. And so you can go to this link here. By the way, most of them are all cern.ch/go links. So the only change is the last 4 characters. So if you write down the 4 characters, you're all set. Organize an event. If you're not participating, or you are, either way, you can participate and organize an event, help as a tutor. And there's more information there on how to get started. If you're at CERN or Fermilab, certainly, and even KK or GSI, it's possible to moderate video conferences with high school students. By the way, Steve mentioned Worldwide Data Day in his talk about IPOC, and that's one where you don't even have to be at a particular institution to be a moderator. So in any case, we always need moderators. We'd love to have you. We provide training. We generally moderate in pairs, and newcomers are put together veterans as much as we can. Contact us if you're interested, please, and look on our website for more info. Thank you.
Thank you. Kenneth, we were slightly losing your voice. Maybe turn off your video, please, if it's connection problem. But I probably understood everything. Yeah, masterclasses are awesome, very popular. I was always curious how hard it is to find CERN operators.
Are there any questions?
The moderators at CERN, this has been a bottleneck in the first years, but it has become more easy to find people who are really willing to moderate, and it's great that you can share the workload on many shoulders. So last year, or this year, the team of moderators was up 60 people. So this is really great. You see that outreach is really becoming acknowledged as a key component, and people try to get engaged.
Can I say at Fermilab, it's a smaller number generally, more like about 20. Yeah, finding moderators is always a challenge, but generally speaking, once they sign on, they're amazingly enthusiastic and really provide wonderful insights to this. Some of my favorite stuff is getting to interact with the moderators.
Are there any other questions? Yes, Yuji?
My question is whether in the long history of masterclasses, did you make some research on the K time of the students' excitement, or in other words, how long they are excited by particle physics, and because there are so many other influences?
Yeah, I think the K time is tough itself, probably tough to study just because it requires a lot of longitudinal study. So I would say that we've had pre and post quizzes before and that sort of thing fairly well. Again, it's true that, a year later were they influenced. And we do know that we've had several people who, have actually gone on to become particle physicists, even come back as tutors or moderators. So it's actually been pretty fulfilling a way to see, that's not going to be the priority of student course, but yeah, I think it's been very heartening to see that we're actually got to the stage where students who did master classes aren't physicists. It's very exciting.
If I can comment, or actually, I was going to ask that question too, something similar. We have done some metrics, right? You and Uta have done some polls, in some cases before master classes and after master classes, to find if there's an increase in interest. And it's true, asking for the decay time is kind of hard, but it would be interesting if sometime we tried to do some long-term study to see what happens. I think one of the most interesting metrics you showed last time I saw a report had a certain number of people who got more interested, and yet there was a very small wedge where people decided they didn't want to do it as a career. And in some parts, that's as important, that someone sees what the research is like and has an attempt at it and decides that that's not what they want to do. But it would be, it's a half question, half comment, that it's interesting to see these things, and perhaps we could do something longer term.
And we can add, even if people decide that they don't want to become a particle physicist, they still value the basic research you are doing. They are willing to give the taxpayer money in this kind of research. They got contact via Masterclass.
Yeah, very, very good point.
Yeah, I think that what you suggest, Steve, is worth discussing further.
Pedro has a hand up, it looks like.
Just to comment that in Portugal do have a large number of participants. We never actually made any professional study, but we know that the students tell their friends how exciting it is, keep coming back. And there are cases where students do participate in several years master classes, so they came back. But from a point of view of student participation, I hope that Anna Peixoto, which is online, and probably in her talk, she might also speak a little bit about it, how she came to particle physics because of a master class. That's it.
Yes, yeah, indeed. I was in the master class in 2010, and then I managed to study enough physics to work now at CERN, and being also moderator at the master classes, and that is great.
Yes, Amber.
Hi, I was wondering, this seems like a fantastic program, and some of the other things that I'm involved with right now include diversity and inclusion efforts. Have you thought about combining this type of program with programs similar to Step Up, which is an APS program to help to encourage more women and underrepresented minorities starting from the high school level to continue in physics? Have you thought about doing something like that?
Yeah, so I can answer this question. Very good question, because we have thought about this, and we have started to offer master classes for girls, not exclusively, but mainly targeting girls. And at the master class, we have moderators and tutors, all female, so they really see the role models. And this we have started 4 years ago. I'll be giving a talk on this in the diversity and inclusion session on Thursday. And we see that there's increasing interest in the institutes. participate in such events. Of course, we don't see the impact now, but it's a little stone we can put, a little piece we can put in this jig puzzle.
Great, thank you so much.
Okay, maybe we should move on now. Thank you, Ta and Kenneth. I have a short question. Do you want to exchange your talks, Uta and Nicolas, to stay within the IPOC, or doesn't matter? Because this was changed on the very last time.
I don't mind, so I think we can have Uta first. She's ready.
Yeah, maybe it's better to keep, because I know that some people wanted to connect and to see the talk. If we now shift, maybe that some people will Nicolas.
Okay, Nicolas, please go ahead.
No, so
sorry.
First now, Nicolas second. Is that okay, or do we change?
Uta, I hear you very badly, but we'll go with Nicolas.
Why?
Sorry, I heard Uta very badly. I thought she suggested to go with you, Nicolas.
No.
No?
That was the other way around. I wanted to proceed.
Okay, sorry. So please,
Is it
Uta.
okay? Yeah, okay. So I'll share my slides. Just a second. So I hope you can see my slides now. There should be
Yes.
Netzwerk Teilchenwelt on the top. Okay. Netzwerk Teilchenwelt, as you might recognize immediately, is a German title, because this is a program which is in Germany, where we are doing outreach in a very coordinated way. And in the same program, we try to attract new talents to this field. And this can be a role model, of course, for more countries. Let's start with a map of Germany showing masterclasses in Germany. So every single W here stands for a masterclass we did in 2019, and every blue dot with number represents multiple events. So for example, you see Dresden is on the hand side where the 6 is. We had 6 masterclasses last year we gave in the Dresden area, plus several masterclasses we did around in the region. And this is an impressive number, 160 masterclasses in Germany in 2019. And of course, all these masterclasses follow the concept that we have just introduced in the talk before. So it's designed for high school students. They hear introductory lectures. They do a hands-on measurement with the same data which are used in the international masterclasses. And all these activities do a result. They lead them fundamental insights in the field. And these masterclasses are usually held at schools. So a physicist goes to a school or a museum or a school lab or a research lab, and there the masterclass is usually given only in very low number of cases. It's given at university. 160, I think it's an impressive number, and this is a consequence of our joint outreach program in Germany, where 30 universities and research labs have joined forces, and they comprise, together with CERN, this Netzwerk Teilchenwelt. And this program was funded 10 years ago, and each dot on this map represents a university or a research lab where experimental particle physics or astroparticle physics is. Oh, I see the chat. Is there something wrong when I'm talking?
No, please go ahead. Sorry.
Okay, sorry, I cannot watch the chat in parallel. This year we started also to include physics from nuclear and hadron physics. I will go deeper into this subject towards the end of my talk. And the main message is, in this Netzwerk Teilchenwelt, we can bundle all the existing activities at the different research labs and universities and we have structures and programs that we share, and this gives the outreach in particle physics a very high visibility and also a high impact. And here's a quote from the RECFA evaluation, which we had several years ago in Germany. And at that time, the committee already stated that activities in Germany are exemplary and they constitute a highly professional way of raising public interest and so on. And just to mention, the project team is at TU Dresden, and there are also teams at DESY in Zeuthen and at CERN. And we have additional hubs situated at University in Bonn, Mainz, and in Münster that help us to do all the work in this Netzwerk Teilchenwelt. The masterclasses are only the first step in a multi-step program, which we offer for high school students. So high school students can go deeper and deeper into the subject following these different activities. They start with a masterclass at school, and in this level we have up to 3,500 students per year. And those who are interested and who want to go deeper in the field, they are invited to more activities. They can actively engage with the research. For example, they can make detector projects and take own data from cosmic rays. And for those who are more interested, we offer 2 workshops at CERN. So they are invited to go to CERN. They have guided tours, they can meet scientists, and they have experiment visits, which are very encouraging for them. And at the top level, we have students doing their own research projects. So they are still high school students, but doing own research projects. There are about 15 of them per year. And some of them are invited to CERN. They can do their research in a group at CERN for 2 weeks, and then they go back to Germany to the place where they live, and in the university nearby they can do the follow-up of this research project. And these projects often have a very high level. The offers for the high school students in the basic program, where we have these big numbers, are of course all the masterclass measurements that Ken and I have introduced in the previous talk. But there's also masterclass with data from astroparticle physics experiments, like the Pierre Auger Observatory or the ICECube masterclasses are used. And there's also a portal which has been developed at DESY in Zeuthen. It is called Cosmic at Web. It's available in German and in English. And there are 9 long-term experiments, and the data sets can be used and analyzed by students with tasks. And there are more offers from this field of hadron and nuclear physics, which we are integrating now, and I'll come back to this later. Concerning the own measurements with particle detectors, we have various sets. We have the scintillator counters, which are the flat boxes, which students can use. And we also have these Cherenkov counters called Kamio-Kanne. And there students can follow various research questions and tasks, detector understanding and lifetime measurement and angle investigation and these physical phenomena. And what's important to say when we look at these 30 research labs in Germany, of course, not everybody is in Atlas or in IceCube, but all these labs can focus on their experiments and activities because there's such a wealth, and so they can choose from this. So looking at the top level where we have the own research projects, here are some examples from students, from high school students who did such a research project, and they are quite advanced. Some of them have already the level of a bachelor thesis. And what you can also hear is that they're pricing in prestigious competitions like Jugendforscht, which is a very high level competition with multi-steps, and some of them got very high prices, and that's them proud, and us, of course, as well. So we have set up a fellow program several years ago. In 2017, which is aiming at a continued motivation of the most interested and students. So if you look at the alumni who visited CERN in one of our workshops, you can see a pie chart on the right-hand side that approximately half of them is already studying physics or physics teacher, whereas 25% are still at high school, and the rest is studying other STEM fields. So we see that they are really entering the physics field, and that's why we started to launch our program to bridge the gap in the school and the research groups, because we want them to be recruited from the research groups. They are already trained and they are already engaged and they're interested in physics, so it would be natural for them to follow up a career in a research group in particle physics. And in this program, we have local offers. They range from internships, excursions, invitations to outreach events. So they are ready to help outreach events. There are also central offers by the coordination, the fellow physics school last year for the first time, which was very successful. We wanted to offer a fellow school again this spring, but it had to be cancelled due to the pandemic. And at a very early stage of their career, we offer them attending national physics conferences. So even in their bachelor studies, they can go to a physics conference and make connections to the research groups. And this helps to build up a close connection between these highly motivated young students and the research groups. In all the activities I have shown so far, the high school students get tutored by so-called facilitators. There are about 150 PhD and master students, and they are engaged in Netzwerk Teilchenwelt, in guiding masterclasses and supervising students' research projects, for example. For this, they get a fee, they get travel cost, and when they travel to a school to give a masterclass there. And we offer also training courses on communication, didactics, and these are important skills also for their own careers when they defend their thesis, when they apply for a scholarship or for funding. They can make use of the skills they have learned in these training courses and also in talking to high school students. And another aspect, of course, is that they are great role models and they can influence students' career-related aspirations and choices.
5 minutes.
Another important target group is teachers as multipliers. And here we are focusing on two things. One is material, where we have developed a plethora of materials. So you see our teaching material for schools has been printed and downloaded in really high numbers. And the other strain is we are focusing on teacher training, where we do 2 days training on an introductory level and also a CERN summer school where teachers really inhale high energy physics. So this successful approach of Teilchenwelt is based on things we provide as a central coordination. This covers structure like a database or an event calendar or a wiki with internal information, and also the material we provide to all these research labs participating in the program, which include also key facilitators, but do-it-yourself, cloud chamber sets and detector sets as well. And we organize central events like the fellow physics school, a fellow meeting, or the training for facilitators. And of course, we do all the communication. We have a web page, we are active on social media, we have newsletters and mailings, so on and so forth. So what are we doing in the current funding period? We are, on the one hand, we are trying to continue and consolidate what we have been doing successfully so far, but we want to reach out to more target groups, and these are the general public and journalists. And we will cover more topics from fields of physics, that is hydrogen and nuclear physics. And for this, we have set up a project which is called Contact. And the important thing is this is really funded as an integral part of research in Germany. So we already have the high recognition and which is as a key component already here. And to implement all the activities we planned in this project, joined forces with a structure that is Weltmaschine in Germany. And here is an impression what Weltmaschine is. So it's the German LHC information point for the public and for the media. And it exists since 2008. They have excellent call to the press, and then also arranged awareness raising central events throughout Germany. They also produced a mobile exhibition, which has been shown in many, many places in Germany. So the new target groups we are targeting are the journalists on the one hand. For this, we arrange a journalist trip to CERN. And on the other hand, we also offer media for our service. And for the target of the more uninterested general public, we have purchased VR headsets and installed apps, and maintenance is provided centrally, but the sets can circulate within our Netzwerk to all the research labs. And the second thing is we are currently setting up an interactive mobile exhibition module, which is quick and easy to set up, and which is targeting people that are not interested in science, who would not attend a public lecture or go to university or to open days. So this tour is planned across Germany, and this module will be shown in shopping malls, in squares, railway stations, all these places. You can address the more uninterested general publics. Coming back to the field of hadron and nuclear physics, which I mentioned before, we plan to offer hadron therapy masterclasses also in Germany, which were mentioned in the talk before. The Bell 2 masterclasses will be offered in Germany. There's a Panda masterclass under development. So Panda is at the FAIR facility in Darmstadt. We have a masterclass on scattering experiments, which is under development. There are several exhibits that will be developed. And there's a one-week summer course for high school students at the MAMI Accelerator in Meirin. And we are also currently arranging a detector school for fellows. So this is from the field of hadron nuclear physics, which is enriching our program. During the lockdown, we had to stop all activities. Now we're restarting with a lot of online offers and adapted concepts. We are doing the masterclasses at home, which Ken has mentioned before. For our fellows, we have offered an online seminar recently, Neutrino Afternoon, which was very successful. Many fellows participated and had a lot of questions. So they had an introductory talk on neutrinos. They had a virtual tour at the Katrin experiment in Karlsruhe. They received a demonstration of a neutrino pendulum by Michael Kubel and a lecture on neutrino oscillations. There are several fellow meetings, social activities going on virtual. We are planning an online seminar for our facilitators, and also the first teacher training at home. Online training will happen in a few weeks from now. Just to summarize what I laid out in this talk is with Netzwerk Teilchenwelt, we have a German-wide network for outreach activities and promoting of young talent with activities at 30 research labs and universities. And these activities range from one-day masterclasses up to own research projects of the high school students. And then we have this fellow program, which bridges the gap between high school students and research groups, and the students are accompanied at universities. They receive technical and personal development and are brought into close contact to the research groups. And the central coordination provides all the structure, material, organization, and communication that's necessary to run this network. The regional hubs foster the integration of the new topics and the new target groups as well. And maybe the most important point, we are funded as integral part of research. So recognition of as a key component of a research program is already here in Germany. And this is a huge achievement for us. So thank you for your thank you for listening and for your attendance. And I'm happy to take questions.
Thank you, Ta. That's quite impressive. May I have a first question, because I'm interested what exactly you show at the shopping malls and who assists there in the mobile exhibition?
Yeah, the mobile exhibition, it has not been shown yet because due to the COVID situation, we cannot go on tour with it. There's a scribble here in the middle of this slide on the top. So it's people walk through a kind of tunnel where they go through the universe and at the Big Bang. And then there are some tables with activities and also interactive parts and some easy and low barrier things that engage. And this hasn't started yet due to the COVID pandemic.
Oh, I see. And you plan to have students located there? Or who's guided?
There will be there will be one person traveling with the exhibition, but the aim is to have also local people from the local university and research lab who help and can also talk to people there. Mm.
Oh, so you have resources to have a person fully employed for this?
Yeah. So the person is currently building this exhibition, and then he will travel with the exhibition.
That's cool. Yeah. Thank you. Please ask other questions. I see no hand. Steve, do you have anything to add?
I think it's quite a wonderful program that they have. Period. Yeah. I don't expect any less from Uta. So.
And Germany.
Okay, then thank you. Then
yeah,
sharing.
Thank you, Nicolas. If you're ready.
I was going to ask perhaps if after the talk of Nicolas, and we're going to have our break, if everyone can just before leaving turn on their videos so we can do a screen capture and have a group photo of us. I think it might be nice for Pedro's talk.
Yes, please.
Okay.
Okay, so can you hear me?
Yes.
Okay, hello everybody. So I'm going to report about the IPOG Global Cosmics Working Group. So I will happily squeeze the first part of the talk that was basically talking about the IPOG collaboration, as you now know everything about it. And I will focus more on the group itself, why it has been created, who are members of it, and what this group is doing. And in particular, I will mention these international events called the International Neon Week and International Cosmic Day. And then in a second part, I will focus on some special projects that all involve cosmic muons, but allow to tackle a lot of different topics. And even if they are not the kind of project that one could easily redo on his or her own, I think they are very interesting and they give a lot of things to think of and to imagine what could be done with cosmic muon educational detectors. As I said, I have slide 4 about IPOG. And then I move to the global cosmics groups on slide 5. So one of the issues that we have in ICHEP is that the experiments we are working on are mostly out of reach for the people. On the other hand, cosmic muons are not, because they are there at a rate of about 1 centimeter square per minute on the ground. So if you have the detector to see them, you can use them directly. So there are many programs worldwide that are using cosmic muons. They are using different detectors, and not only the technology, but also the size of the device, the way to access it, how straightforward or difficult it is to use it, and so on. And in all cases, I think they are trying to make some application based on those detectors and to connect these studies to the curriculum in the different countries. So the Global Cosmic Initiative is really seeking for synergies among all these projects. And one of the good things of IPOC that we provide a forum where expert people can meet, discuss, exchange ideas, and so on. So there have been already attempts in the past to try to federate all those detectors, but that did not really work for various reasons. So the starting point of this current effort was a workshop that was now a bit more than 3 years ago in Rome, and you can find the link to all the talks. And currently, this table is showing all the participating projects. So the first one gives you the country, then the of the project. Finally, the last column is the website. So there are very diverse projects, focusing some on outreach, or on education, or on citizen science. And this list is meant to be very inclusive in the sense that if you don't see your favorite project or a project that you know listed here, don't worry, just contact IPOC people and they will be happy to add it to the list. So let's look at some of these projects. So these are just examples. So on the top left part, you see this Cosmo detector from France. There are about 50 of these detectors, and they look like round. And in fact, we call them a cosmic wheel because you can basically rotate the detector so that you can measure distributions at various angles. There is also a project in Spain where you can do a software analysis in Python of magic data. There is also an underground lab in Finland called Kallio, where cosmic ray experiments are done, and so you can look at the data. One of the recent projects in France is called Hyperon. This is a virtual lab at the top of the Pic du Midi mountain in the Pyrenees, where there is an observatory. So you have various detectors that are here taking data, and teachers and students can connect through a web interface, get those data and analyze them. Cosmic at Web in Germany, there will be a dedicated slide later on. Then at the bottom right corner, you have Shower of Knowledge in Russia, where they have basically arrays of detectors to the atmospheric showers. More examples. So there is a project in Sweden where high school work on cosmic rays. There is the famous iSpark project on the Netherlands and in the UK, where you have basically detectors installed on the roofs of high schools, and the data are shared and analyzed globally. In Italy, you have this extremely impressive extreme energy events project led by Centro Fermi in Roma, where you have detectors in many schools, and all the data are sent to the CNAF Computing Center and can be analyzed globally, also by schools which don't have a detector yet. You have this citizen science Credo project in Poland, where particles are detected by smartphone cameras and then centrally analyzed. I'm not going to talk about Netzwerk Teilchenwelt because you just had a talk from Utah about it. And finally, there is this QuarkNet project in the US, but also I think there are labs participating in Europe and in Asia, where they also have set up to detect cosmic rays. So the Global Cosmic Group is an open group, and there is a mailing list. So if you want to subscribe to it, just contact us. Usually the groups meet through teleconferences, and also we try to meet in person once a year at the IPOG spring meeting. As you know, there are 2 IPOG meetings, one in spring, the other one in fall. And there is a dedicated website hosted by Daisy in Germany, where you can find the list I showed before and more information on all these projects. Then the group is growing, and so there is an emphasis to have more internationally targeting events. One of them is this International Neon Week organized by QuarkNet, where basically the teams who are participating from high school should let the detectors run all the time, and then the data are shared on a common website. I don't think there was one event this year due to the pandemic, but last year there were more than 50 participating groups, and you have the map that you can see, and you see a cluster that many of them were from Italy, these triple E projects I mentioned before. Then there is another international event for students and teachers called the International Cosmic Day that is organized by Daisy. And here there is a topic that is selected every year, and all the groups are asked to work on that same topic. The idea is to work a bit like a big international collaboration. The results are discussed in video conferences, and each group can contribute to a set of proceedings. So each year, the ICD edits a nice booklet that I think was very thick, close to 200 pages last year. And there are additional events like a quiz and things on social media as well. And the last edition was last November before the pandemic. And again, Italy is a strongly participating country. And finally, the histogram at the bottom shows you how the number of participants has grown with the years. And I think that's a very good thing, and that shows that this project is triggering a lot of interest. Then moving on to some special projects that I have selected. It's maybe a bit biased, or at least it's my own selection, but I have thought that they were very interesting, even if, as I said in the introduction, these are not things that you can easily redo on your own, but at least they should open up our minds and give us ideas for the future. So some of these projects will be targeting the polar parts of the world. The first one is Polar Quest, that is part of this Triple E project. And the idea was to refer to the anniversary of some Italian expedition 90 years ago, to have a cosmic neon detector sailing to the North Pole on this boat. And the detectors were built at CERN by high school students, like I think all the EEE detectors. 3 of them were built for this experiment. One was on the boat, a second one in Norway, and the third one remained in Italy, in Torino. And here on the map, you can see that the path of the boat from Iceland to Norway, Finland. Okay, and here at the top right, you can see the corrected rate of cosmic muon in Hertz as a function of the time. And I think the key word is corrected, in the sense that the students looked at the raw data, but also had to correct the rate to account for barometric effect, and also to the inclination of the boat. And I think they had some nice event like the one shown on the pictures, where the boat was actually tilted a bit, so they could check that their correction was working fine. And again, this is the path of the boat, with the color code showing you the corrected rate as a function in Earth. So there is also another boat that is called the Polar Stern from Germany, which I think has been running on the world for like 10 years, and it has some scintillating counters on the board. And the good thing is that there is a website called Cosmic@Web, where you can download data from this experiment and also from 8 other experiments, and then you can analyze them remotely at your school, for instance.
5 minutes to go.
Okay. Another thing was this physics at an international hot air balloon festival event that was organized in Switzerland, in a rural place that is called Château d'Eux, and that is near Gruyère, I think. And for like 40 years, they have organized every year an hot air balloon festival. And physicists received some invitations to come and be part of this festival this year. The connection with cosmic muon is quite obvious because, as you know, a century ago, people were using balloons to study how the ionization evolves with altitude. And the good thing is that there was a local physicist called Albert Gockel, who was one of these pioneer people. So really, this invitation was seen by physicists as an occasion to talk about physics. And so they came up with an art and science collaborative exhibition on cosmic ray discoveries with balloons. And obviously, when you talk about cosmic rays, then you can switch to particles, then you can switch to the universe, to CERN, to LHC, etc. So really, cosmic rays and balloons were the way to bring people into modern science. This exhibition had originally items on display. There was an art component, as I said. And I think it was a very successful operation in the sense that the museum saw a significant increase in the number of visitors associated with this exhibition. And finally, they did this balloon fly with modern cosmic muon detectors on board. Another project I would like to mention is something that is currently going on in La Réunion, which is a small French island east of Madagascar. So you can feel that it's very far from mainland France, from CERN, from labs and so on. But here there are a small group of teachers who decided to work around those difficulties and use the location as best as possible to organize some activities for high school students. So obviously, they managed to get some cosmic ray detectors, and they go high up the mountain because La Réunion was born from a volcanic spot, so quite high mountains there, but the island is quite small. It's surrounded by sea, as you can imagine, and that will play a role in the next slide. And also, it's on the southern hemisphere, so it's a base for French mission to South Pole. So we met one of those teachers who was participating to the French teacher program at CERN 7 years ago, and he made a kind of workshop of the two infinities locally. And since then, we have a lot of contacts with them. We have teachers from Réunion coming every year to the French teacher program and so on and so forth. They are participating to mainly contests, organizing scientific trips, etc. And they have one of these Cosmo detectors I mentioned briefly at the beginning, and I think that's the only one that is overseas. And they also managed to get this small case that is called Cosmix, that is a portable cosmic muon detector, and really they made the most of it. So one of the things that is maybe not too difficult is to take it on a commercial flight, so you can see how the rate of cosmic muon goes up with altitude. But they also made more things, like they dived at 50 meters below sea level to measure the water attenuation power. So they removed the detector from the case and managed to put it in a sealed tube that you can see here. And they also shipped the case on a boat that was going to the French southern and Antarctic lands. So that's the same case that you can see here, that you see with some penguins on the background. And really, the next step is Antarctica. given that this first mission was a success, they managed to make some agreement with the French Navy, and sooner or later, this detector will go to Antarctica. So as a conclusion, this new IPOC group is, I think, reaching increasing speed. That's really a forum to bring together this project. And it provides educational products. There are also scientific endeavors, these booklets I mentioned for the ICD. There are events that can be attended worldwide. Of course, some activities were delayed or slowed down by the pandemic, but I hope things will restart again. And one good thing also is that this allows people to report about what they are doing, what they plan to do, and I think it's a really good thing because it gives ideas, it shows creativity, and it shows how you can adapt to whatever your environment is, whatever your resources are, and trying to do something interesting for the students. So as a conclusion, Cosmic Muons are really the front door for global multidisciplinary projects. And you can reach a lot of audiences with that. And you can have direct involvement from the public. And that's really, I see that as a concrete entry point. And from there, if you find the good topic, the good arguments, you can lead the people to a more state-of-the-art science like what we are doing at CERN. Thank you.
Thank you, Nicolas. I especially like the Polar Quest because it was Czech scientists on board of Airship Italia in 1928. Yes, Carlson. Benjamin, sorry.
Hi, can you hear me?
Yes.
Yeah, so I had a question about the Polar Quest expedition. So are these, so two questions. One is the technical question. What kind of detector did the high school students build? And the second question is about the nature of the mission. So I assume it's not just sending cosmic ray detectors to the poles. So I was wondering if you could elaborate on what else is on board that yacht.
Okay, I'm not working on this project directly, but I see, for instance, that Despina is online. So I don't know if Despina, you would like to
Yes.
answer. Okay,
Yes.
Great.
Well, about the type of detector, the detectors were plastic scintillators with silicon photomultipliers, if that was the question. And the other,
that was part of it.
Yes, and the other thing about initially the idea was to have detectors similar to the ones of the Extreme Energy Events project, which are multi-gap resistive plate chambers, but of course it was not practical. So we switched to scintillators. Concerning the mission, I think, okay, one thing was to find maybe what remained from this expedition 90 years ago. And then they also had other scientific goals. I think they were collecting samples from the water to study microplastics. I think there was something about taking some type of photographs to make a map of the area or something. So this was one of many projects, the measurement of the rate of cosmic rays. So I hope I have answered at least partly.
Yeah, no, that's basically what I was interested in. Thanks.
Okay. Maybe this is Steve. I should raise my hand, but I don't think I can as a co-host. I have one question. I don't know if either of you can answer, but I'm always curious about is if a classroom found out about any of these projects, where would they go to see how they could build their own detector and get involved? I suppose it's different for each of the projects. But is this a goal of IPOG to be that place where they can get that information?
I can answer for the French detectors. I don't think there are plans or instructions that would allow students to build really their detectors. We have ways to access the data or to ask to get one detector for loan, but I don't think we have instructions now for students to build their own detector, at least on the French side.
Sorry, can I answer about the Extreme Energy Events project?
Sure.
Well, this is basically an Italian project. I think there are also some schools which are non-Italian, which are connected, not having a detector, but so that they can analyze data and so on. I believe on the site where all the projects appear, there must be the link to Centro Fermi, where there is the description of the project and so on. So in principle, people interested, they can communicate with the management of the project and take it from there. But at least up to now, since it's Italian, I mean, the money comes from Italy, if somebody non-Italian wants to participate, I guess they would have to finance their own detector. But okay, it's always a question of discussing with the management of the project.
Okay, that's very good. I guess perhaps that's one thing we can aim towards with IPOG is to make it easy for someone to find out who they should get in touch with and what their different options are. Okay, I guess we're at break. Is that right, Miro?
Well, you wanted to share videos.
Yes, I think that'd be great if everybody can just hold on a second. I'm going to put up the big grid. We're a big matrix here
to check if they're really here.
Yeah,
Wow.
how big, how I can get. There's one of two, so I have to do 2 screen captures. Okay, so I'll
You can change your settings to have 50 on your screen at once.
I can. Tell me how.
Yeah. Good question. I know it's possible. Video settings.
On the top of the screen, right corner, there is an icon.
There's the speaker's view icon, right-hand corner. I see speaker view, but I don't see how to set.
So I have, if you click the up arrow on the video and you go to video settings, and then at the bottom of meetings, it says display up to 49 participants per screen in gallery view.
Oh, I see it. Okay, click. Okay, let's see what that gets everybody on one screen, 7 by 7. Okay, I got as big as my screen can be. And I'll put up my, I'll do a screenshot.
Tell us when to smile.
Actually, I should do a video, but then it's a bit more effort there.
I can do a video if you want people to wave, but it won't have sound in it.
Yeah. Actually, I mean, it's actually easy to do. You just do record selected portion.
Well, we are recorded. It will be on YouTube. You can cut it off.
That's true. It's going to be there too, but I'm gonna put this on. Okay, so let's see. It will do it in 5 seconds. So I'm going to click the button. In 5 seconds, we all have to wave. Okay, ready? Okay, wave. Okay, I think I must have something.
Well, I took the liberty to take a screen capture.
Good. Okay. So we should have, between the two, we should have something. Okay. Good. Thank you. Whoever wants to stick around, I'm just going to get some water or coffee or something, and we're free to have a coffee break together if you like.
But be aware that I think we're still being streamed on YouTube. So
okay, be careful.
Don't be mean about anyone.
Darn. All right.
Do you agree to return 70:30 or?
Yeah, we're actually almost time to start up again, right? But that's okay.
Is 50 minutes okay for you?
Yeah, let's do 17:30 sounds good. And I'm just gonna take a break for a few minutes, get something to drink, and then I'll be back here if anybody wants to talk.
Yeah, feel free to discuss here.
But he's still connected?
Somebody's still connected, yes. Let me share my...
I got my break.
Let me share also my...
Do we have
cup,
conference
my
live
coffee.
streams?
I hope your screen capture worked, Pedro, because I tried to screen capture a video and it nearly crashed my computer.
No, I think it worked. I can share it on the chat window. I don't know if I can. I can share it on Mattermost.
I don't hear you.
People
I
have
think
to
you're muted.
practice Mattermost. Let me see. It says I can attach a file. So let me attach this screen capture.
It's my problem.
Uploading.
Can you try? Are you? You can hear me.
I can hear you
I
nicely.
can't hear you.
Oh. Oh, you can hear me?
I can hear you both.
Oh, thank you.
Muriel, are you unmuted?
No, I was shocked because I was unmuted.
It could be that my system screwed up and I have to reboot.
I have loaded the image to our Matterchat channel, Mattermost channel. This way people have to go to Mattermost and download it's 5 megabytes. Astonishing. I didn't realize it was so.
Where is it, Pedro? Is it there?
In Mattermost.
Have you shared it on the education and outreach
Supposedly, it's on the Education and Outreach channel, yes.
Okay, maybe it takes time.
The last one I see is Kauri Veteli.
Oh, wait, let me see. Yes.
Kauri.
Maybe I have to write something because I have uploaded.
I hear now. Somehow I had
Pedro
a screw up.
was typing. Okay.
Okay, I had to write something.
Good. Okay.
I thought upload was enough, but
Okay.
and of course I'm not waving because I'm trying to press the button to screen
But
capture.
not everyone is here, no? Not everyone is on the picture.
No, not everyone. There were at least 5 people with cameras off, and one of them was in. Well, she told that she would not be able to connect video.
Well, we can go
she
through.
promised to send a picture by mail or so.
Okay. There's
But
a
Steve,
recording.
what I propose is that you do a screen capture of every session.
Yeah.
And then we'll make a composition.
Okay.
It also looks will be much more people, like 8 times.
I have moved outside. We had a storm come through. And
You
it's
had a
so
lot
much
of
cooler
wind through your talk, indeed.
here. My talk? I was
in
indoors.
your talk, there was a bit of, but it was windy. It looked.
It was
like.
probably in my head.
So coffee, good coffee to everybody. I also have cookies. I don't know if you want. Who wants cookies?
I have ice cream.
I have chocolate.
So actually, I should check the other chat to see if anybody wrote in there. I don't know, Miro, did you have a chance to look? Oops. That's me. I have the birds chirping.
Yes, certainly. Series of physics webinars over the summer at his YouTube account.
So I say, Ben, if you want to put up your slides, I think, I don't know if you can steal the screen or if we have to unshare.
It looks like you have to stop sharing. You know, there's a need to be able to share.
There we go. We were heard.
I did.
Thanks.
There it is. Sorry, I have a lot of windows and I lost it.
Okay.
Found it.
Well, I should answer. I was asked about if you don't want to have your video up when you give a talk, but you like to have your image up, you can do that by having a profile image, and or you can just turn off your video and there won't be anything. But it's nice to see something so we can see who's talking. Okay, so we're going to learn about Atlas Virtual Visits and then about CMS Virtual Visits. Let's see how the visit Cold War is coming along. So Ben, would you like to start first with Atlas?
All right, thank you very much. Yeah, I'm going to talk about Atlas Virtual Visits. I am Ben Carlson. I'm a postdoc. I work on the Atlas experiment, and I've been working on the Atlas experiment for about 5 years. So yeah, I'm going to tell you about how our impressive detector can be shared with people around the world using technology. So I'll start by talking just a little bit about the Atlas experiment and the Atlas collaboration and how we can use the diversity of the collaboration along with technology to bring the detector and the interesting physics that we work on at the LHC and Atlas in particular to people around the world. So I'll tell you then what a virtual visit is, and then tell you who has visited, and then how you can change the statistics by booking your own visit. So the Large Hadron Collider is the highest energy particle accelerator in the world. You can see it in this picture from an aerial view where the accelerator, which is of course underground, has been overlaid in red. It's 27 kilometers in circumference. And just to give you a sense of scale, I drew on where the airport is. And around this point, we have the Atlas detector, which is what we use to study the collisions that occur when the protons collide from the LHC. This is a mural that sits above the Atlas experiment and shows you in roughly a real scale what is going on or what's underground at the interaction point. And you can see some sketches of the proton interactions leaving their signatures in the Atlas detector, which is just a snapshot or a picture of these events. The Atlas detector itself is a very impressive device, which is an interesting thing to be able to explain to people. It's impressive in scale in the sense that it's 140 feet long or 44 meters long and 25 meters or 80 feet high. And you can see the people overlaid here just to give a sense of scale. It's also very sophisticated in technology. And one way that you can quantify that, in addition to technical definitions of how well we can measure different kinds of particles, is just the number of readout channels. So we have about 100 million individual channels that we record data on in order to study the events that are, study the collisions of the Large Hadron Collider. The collaboration itself is impressive as well for different reasons. It's one of the largest experiments in the world, has 3,000 authors on all of the publications that are distributed around the world in 38 countries and approximately 183 institutes. If you follow the link and zoom in, you can see where these institutes are around the world and who is actually working on the experiment. But the main message of all of these slides is that we have a very interesting detector. There's a lot of things that are just really cool when you look at the experiment. It's very interesting way to connect with people. And the experiment itself is globally connected. People are around the world. There's people from even more countries than are listed on this slide. And it's a way to bring science to people to see the action at CERN. So now I'll tell you a little bit about what actually happens during these visits. So the first thing is that the audience connects to the Atlas control room and then sometimes the cavern via video conferencing software. There's usually a brief introduction from guides. These guides will tell you something about themselves, what they're interested in, what drives them, and then what the goals are for the Atlas experiment, which are, of course, often directed by the interests of the people, as well as giving the visit, as well as the questions people ask. And there's also a detailed question and answer period where the audience can virtually ask questions about the kind of physics that's done at the Large Hadron Collider. And then when possible, there's actually the possibility to take a camera into the cavern and show people the Atlas detector itself. This is an image from the CERN database showing you some of the muon detectors at the end of the experiment. So that's the kind of visual that can go along with these visits. And then, of course, you can also see the guides in the control room before you go down, along with the virtual audience on the right. These are more scenes from some visits. So, for example, you can see the control room, which has all of these different panels. So you can explain, you can have this backdrop where you can see actual work going on in the Atlas experiment, where you can see things like the trigger details on the left-hand side, how the information is coming into the experiment. Can we monitor details of the detector cooling system, and just the level of complexity that goes on is right there in these visits. And then, of course, there's a host that will be there to answer questions and introduce themselves, along with a direct connection to all of the visitors in another part of the world. So to visit, there are people that visit from around the world. You can see each of these dots is where a visit happened in 2019. There were about 75 visits in 6 populated continents. So you can see that there's a lot of people from all around the world connecting to see what's going on in the Atlas experiment. There's also a variety of audiences and venues. So you see things like arts festivals, teachers and students connecting for all different kinds of reasons and interest groups. Some of these are recorded, so you can go to this website and you can have a look at them and see what kinds of questions people ask. Some numbers on who visits in terms of country. You can see this is a pie chart showing the different fractions of people around the world connecting. You can see that there's lots of visits from all around the world, with a few, with of course Brazil dominating the number of visits. Then the similar distribution by language, not surprisingly, since Brazil has some of visits, Portuguese has a large fraction, and as does English, but there's also a lot of other languages that are a possibility, depending on who can actually host these. You can check out some examples. You can look at the little promotional video that's about 2 minutes long on the right-hand side. You can follow the link there to see very briefly what the visits are like. And you can also look at a number of, but I've linked one particular pre-recorded visit where you can look through and see what actually happened in this visit. In this particular one, in the link I showed here, they actually go into the cavern, so you can see what that's like. So then the question is, how do you book a visit? So there are some technical requirements. You have to have video conferencing software with a sufficient internet connection. You do have to fill out a little bit of paperwork and give some notice, because people have to actually plan to be able to host a visit and make sure, if possible, that it can fit with the work schedule in the cavern. And then you do have to commit to things like testing your video connection to make sure that it actually works. But here's the link. If you have a group that you would like to register, you can do that at this link here. And one thing to note is that even though the pandemic is going on now, it doesn't mean that it's impossible to do a visit. There are hosts that are able to connect from home, and of course that means you can't go into the cavern, but it does mean that you can still have the question and answer and discussion with scientists part of the visit. So that is still possible, and things are slowly opening up, so slowly some visits may be possible in the future. So the last thing, in conclusion, is just an advertisement. If you want to see what an actual visit looks like, there will be a visit on the 5th of August at 2 p.m. You can, as part of ICHEP, you can follow the link here, and you can see an actual underground visit to the Atlas experiment. So that's all I have. Thank you very much, and yeah, it's very exciting to be able to connect the science that we do to audiences around the world.
Okay, thank you very much, Ben, for presenting that. Going to look for hands. Who has a hand up? There's a hand. Pedro.
Ben, thank you very much for your talk. 2 questions. Can you please upload your slides? Because I didn't find them in Indico. Maybe I have to reload. I don't know.
Yeah, you have to reload.
Okay. The second question: can we popularize this big band stage amongst our communities? It will be made via YouTube, video, or Zoom.
So I don't know if that's the virtual visits part of that. I can maybe comment on the Big Bang stage. That we're gonna try to do some publicity in the coming day. I think that I was waiting for ICHEP. ICHEP was going to put out something on social media, so we have to coordinate that. And but there will be something coming out soon on that. And it will be broadcast on YouTube. Anybody will be able to watch that event.
But it will be broadcasted live.
It will be live.
Okay. Then we'll just okay.
Yeah, and there will be possibility for questions and answers as well.
And how will this be managed then?
There's a software called Slido, SLI.do, and so people can pose questions and then vote them up, and we can monitor them. I don't know if that will work well for the virtual visit, but I don't know how they're planning to do that. I'd imagine that they will try to answer some questions. I know that for universal science, we rely on questions and answers. I would just add quickly to what Ben said. Was a very nice summary. That the real goal of these, I think CMS will probably confirm as well, is just that the interaction, getting questions from people, and by being next to this incredible device, just draws lots and lots and lots of questions, and so it's a really great opportunity for us to interact with people.
No, but let me stress, these virtual visits from Atlas and CMS are a huge tool for the teachers with their students in faraway countries like Brazil, where coming physically to CERN is so difficult.
Is there anybody else who has questions? Okay. Well, let's thank Ben, and
thank you.
We should move on. I have too many screens open. So Cecilia, you are going to join us next.
Yes.
Tell us how CMS is doing virtual visits as well.
Yes, that's correct. I'm going to share my screen now.
Okay.
Perfect.
Very good.
Can I start?
Go ahead.
Okay. Hello. Good day, everyone. I'm going to talk about CMS Virtual Visits. Sorry. Okay. So as some people already have explained, these virtual visits are quite interesting because it's a way to reach the general public. So we can actually connect them and so they can see our experiment if possible when the site is open, the cavern is open, we can actually go down there and show the nice experiment that we have. And so the requirements actually for the virtual visit are quite straightforward. So for example, they just need basically a computer with a network speed of minimum 1 megabits per second, a video projector, and preferably a dream room, and a microphone, and noise cancellation, which is important as well. And then they need to have something like video, Skype, or Zoom for the connection itself. So we have seen that the virtual visits work better. Usually we have at least 2 scientists inside. So one could be, for example, in the surface of the experiment, in the control room could be, and then the other one can take the camera and go down to the experiment if possible. And obviously there is the team that is in charge of the technical transmission, the video, the sound, the recording, etc. At the venue, we want at least 1 scientist or a coordinator. That could be a teacher in the school, for example. And so it is advised as well that if possible, this scientist or coordinator gives an introduction of CMS, because then obviously the public can understand better what we're doing, and then they can have even more questions during the virtual visits, and as well to break the ice, let's say. So these virtual visits are recorded and they are kept in a permanent site. So then people that are interested can go there as well and watch the videos. Or if someone, a scientist, is interested in and trying to bring a virtual visit or something to a school, they would have a better idea what we do and so what the virtual visits are for. And so it's very important as well after the virtual visit to have a feedback from the public, because in that way we will understand better if this is important for them or what they would like to hear from us. And so we have room to improve. And so this feedback is always very, very important for us. So the public usually are students, teachers, or general public. And so this is really the virtual visits unique opportunity to show people what we're doing at CERN, what the science is about. And so we can reach even the students that maybe are not going to go into science, but many times we can make these connections and we can let the people know exactly how the physics connects to basically every technology that we can possibly think of. And so we have some examples here, and scientists from Iran showing the detector, and then we have some other students in the university in Mexico during a virtual visit. The other interesting thing as well is that because we have so many people working at CMS from so many different countries, we can actually bring the virtual visits in the preferred language of the public. So then this is really, really important, I think, because many of the material in general in the internet is mostly in English. I'm from Mexico, obviously, and if you present a talk in English with subtitles or with a translator, is good, but is not very good enough for people that don't speak English at all. So bringing these virtual visits in Spanish, for example, in the case of the Mexican students or even the general public, is very good, because then people are more ease and more relaxed about using their own, words to express the feelings or to ask questions. And I think this is really, really important. So, and the nicest thing as well is that, for example, here during the Researchers' Night, we have this virtual visit, and not just for Mexico or several schools in Mexico, but we can reach places like Colombia or Chile or other places that speak Spanish and can be in the time zone that is appropriate for these visits for them. And so it's very nice, because then you can certainly reach a broader public in the same language, and it has been very, very successful, actually. So with the outreach activities, obviously, besides the virtual visits, include other master classes, as Yuta and other people have told us already, and Ken from Northwestern as well University. So here, for example, we have some pictures from different schools in Mexico as well, with different events like master classes and like international cosmic daemons and things like that. And it's very nice, because many of these students, actually, before we organize all these visits and all these outreach events, they didn't know exactly what a physicist can do. And for example, in a particular picture here, there is a student, a female student, that didn't know much about physics before these events. And then now she is actually in my university studying physics, thanks to all these outreach events, because then she knew better what physicists can do, and then she was very interested. So the feedback that we have from different events, that like virtual visits, is very good, has been very enthusiastic. And many of the students, actually, even when they are not planning to go into science, these events are really important, because they can actually make the connections with other areas that they are planning to pursue. For example, a student here is talking about that she wants to study medicine, and so it was for her very interesting to make the connection, actually, of how particle physics actually can help that area. So then, so far, basically all the students that have been participated in these events, in our experience, is that they become more interested in science in general. Some of them actually pursue a career in physics after these events that we have, and others are just very happy, you know, that we give them this information so they can actually see better what a scientist can do. I want to talk about some numbers now. So, for example, for the virtual visit, the participants of these virtual visits per year and per month, obviously the outreach group is in charge of taking all these numbers and putting them together. So, and here, for example, we have these visits. We started from 2014 till today. And then we have here, for example, in 2016, we have most of the participants. And then, so the second biggest participation was in 2015. This is because actually the visits now have reduced to 4 per month because of the works that are going on in the site, in the P5, in the detector. So that's the reason why you can see let's say a decrease in recent years. And well, obviously 2020, for obvious reason, because of the COVID, we cannot have as many virtual visits as we wanted. But obviously, as soon as we can go back, we are going to take over again this enterprise that is very important. So you can see as well here in this histogram is the month, so from January to December, and in the different years. So you can see actually what months are more popular as well for these visits. And then I want to show you as well some charts here for the main reasons and the type of audiences that we have in the virtual visits. As you can see here, the biggest one is the school events. And then the second one is the open days and public events, but we have other as well as conferences or teachers workshop or university events, etc. And then connected obviously to this chart, we have the type of audiences, and then you can see that the high schools actually represent the biggest like a number of participation with 53.2% here. And the second one would be the general public. So here you see that the grand total is around 33,000 participations, which is actually quite impressive. And then we have here a map, so you can see globally how this participation is seen in the world. This needs probably to be updated, but in general, you have the idea. Basically, we have around 40 countries participating with the virtual visits, and obviously we want to reach much more. And here are the top 14 countries. So you can see here that, for example, Greece is one of the most active participating in the virtual visits. And we have other countries, and it's good to know, as you can see, that all are all over the world. Even like in the 14 countries, we have places from Europe, from America, from South America as well. So it's quite nice to see this participation. And obviously, if you want to reach wider audiences, you need to make international partnerships. These are very, very important, because then obviously they have already a public, and then we can connect the different events happening around the schools. And this is very important, because then obviously we have more people attending our virtual visits. For example, we had a partnership during this COVID pandemic. So the International Masterclasses, the QuarkNet, and the International Particle Physics Outreach Group implemented the first large totally online masterclass. So this was called BAM-C, that is for Big Analysis and Muons in CMS. Ken already talked a little bit about this. And I just want to mention some other little details. For example, this was done on the week the 13th of April. And so we didn't know actually if this kind of masterclass, because it was totally online. Usually masterclasses are more personal. We go to the schools, we actually interact with the students directly and show them how to do the analysis. But this time was totally online. So we have to organize, for example, different meetings along the way the week. And so we can actually teach the students online how to do the analysis. And then they had to attend if they wanted another talk, for example, for CMS. And then obviously we have to analyze the data. And the option was that we could do it the same day that we were to discuss the results, or we can do it in advance. So in Mexico, with different schools, we decided to do it in advance. And so around 23 international schools were attending this event, 4 countries, and over 230 students analyzed almost 12,000 CMS events in 2 days. And then the ones attending the webinar were around 180 students and teachers. So this was a very, very good, very big success. And because of that, actually, another event was organized in May. And obviously it was bigger because we knew what to do. And so around 460 students worldwide with more schools were attending. And so almost 24,000 events were analyzed during this second online masterclass. And So we, as you know, with the COVID-19 pandemic, so we have to rethink how to teach our students how to contact them in their houses with sometimes limited resources and things like that. And we think that actually events such as BAMC could help the educators and could help the students with this new reality. Obviously, we need to implement and we need to change sometimes for example, the master classes. We have to simplify them because obviously it's not the same to go in person and teach the students that doing everything online. But we have seen that with different events that this has been a success. And so we are very hopeful that we can still helping educators and we can continue inspiring students to acquire knowledge. So in those terms as well, for example, one of my colleagues working at CMS and myself decided as well to have a webinar related to particle physics on June 12th. And then we started just with our students in our university. We decided that we wanted to have this webinar, and then but we told our students, you know, I mean, you can invite your families, you can invite other students if you want, it's open, so no problem. And we were thinking that we will have around 20 students or 30 students, and actually it was we at the end had around 130 people attending the webinar, not just students from our universities, but from other universities and even families connected to the students or other general public. And so the students expressed a lot of enthusiasm. We have a lot of questions during the seminar. And so they were eager to have more of these events because they said that it was very refreshing to learn how science works in these big experiments. And especially now that they are recluded at home, that they have to stay there, it was like opening a window to a different world, and they were very, very happy and inspired about it. So if you want to get involved, we need you. We need your enthusiasm, and it's, as I said, very straightforward to do it. You could be, for example, a coordinator. You can bring a virtual visit to a local school. And so for that, it's better to talk to your IPOC representative, the outreach group, obviously in CMS. And so because they can help you to coordinate the virtual visits, and you can have not just one virtual visit, as I already said, you can actually connect several schools at the same time in your country or even abroad in other countries. And so this, as I said, is very nice, it's very rewarding. The students are really going to appreciate this, and the general public would be more aware why science is important, and we can help educators as well to inspire students. And if you are at CERN, you can as well help because you can join the team of guides, and you can be, for example, in the experiment site, or you can be explaining, for example, in the control room how everything works in CMS. If you want more information, you can obviously go to the website for the virtual visits, the CMS Virtual Visits, or you can contact the outreach group. And so we have some links as well of photos and videos where you actually can see what is this about. And so finally, I want to thank the CMS outreach group for organizing the virtual visits and for collecting all the data that is connected to these events. And I want to thank as well Marcena Lavka and for providing a lot of the information that I use in my talk. And as well, I want to thank Naomi and Sultan, because these are basically the team, the technical team that help us to keep these virtual visits going and being recorded. And so they are actually like connecting like 1 week, for example, before the virtual visit happens with the school, just to be sure that everything is in place and that the connection is not going to have any troubles at all. So thank you to them, to Naomi and Sultan as well for the big help. So I want to thank everybody for your attention.
Thank you very much, Cecilia. That was very, very nice to hear. I think that I would just make a quick comment and maybe look for questions. I think that, both you and Ben brought out some very important points. And one of them is the influence that this has. You mentioned a young student who became a student because of going to a virtual visit. That happens in Masterclasses a lot as well. I think that also emphasizes perhaps the importance that we bring to these visits as hosts, role models. As we all know, our field is fantastic as far as diversity when we talk about people coming from various countries and different corners of the globe. But we are terrible when it comes to having women in our field and retaining them. So I think one thing we've been trying to do with our virtual visits in Atlas is as much as possible trying to bring in young women hosts to act as role models for classrooms. I don't know if CMS has considered that or not, but I think that it's an opportunity that we have.
Yeah, no, definitely. You touch a very, very important point. I think that many of the women that we have been having in these virtual visits, obviously these are open for everybody, but we have many of the students are women. And they were, many of them were very impressed because they thought that physics was basically, especially in Mexico, because we tried to go to remote places as well, not just in the city. We really tried to reach the students that sometimes actually don't really have the connection, to go a university or talk to a professor in the university. So we really tried to go to like high schools and in remote places to bring all this knowledge to them. And so in many of these visits or outreach events, many of the women were very impressed because they thought that basically physics was for men. And so they were very happy to see actually women participating in these big experiments. And like for them, it was like, okay, I can do this. This sounds really interesting, and so they were more curious to understand how to go into this field. So we have seen that a lot, and I think this is the reason why these events are very important, and try to reach as much public as possible. This is very, very good.
That's great. That's great. And perhaps we have an opportunity now. Maybe COVID-19 has brought us an opportunity with more people learning how to use Zoom and being able to take classes with Zoom, that there's audiences out there who are ready to connect with us.
Yeah, right. It makes us actually, I mean, at the beginning it was worrisome, right? Because we thought, now basically we're stuck here. We cannot go to schools. We cannot. But yes, I think this, instead of being something defeating, was, as you say, very important, because now the public knows how to use different tools, including Zoom. And so this is another window, because now people are less afraid, to connect to the webinars or to go to a lecture online. And so then actually it was a good thing that now we can do, and we have been testing this, with the master classes online, with the webinars, and it has been a success. So we are very, very happy actually to see that we can even reach more broader audiences, because sometimes some of the students cannot come to the university, and now we know that if they have a computer, it doesn't matter where they are. Even in remote places, they can actually connect remotely and attend the visits as well.
Great, great. Are there any other questions? I don't want to hog questions. I'm looking for hands, or just speak up if I don't see your hand. Okay, I don't see any hands.
Okay.
Well, I'll make one last comment because I can't help it. But actually, it was to Ben. Ben, you have to change one of your slides. We've actually had all 7 continents come to Atlas through our virtual visit center there.
I discovered that, and I was considering making that link. We should include IceCube again. Right.
Yeah. They weren't exactly visitors. We kind of visited them, but doesn't matter. Detail. Okay. Thank you very much, both of you. And
Thank you.
And we should move on. I wish I didn't have so many screens up that I can't see where we're at here. Oops. There we go. Okay, so we're going to Anna, and we're going to learn about virtual reality and how that is helping us. So Anna, have you got your slides?
Can you hear me fine?
Yes, we can.
Perfect. Okay. Good afternoon. My name is Anna. I'm from Portugal. I am a PhD student from Atlas. And today I'm going to talk about how the virtual reality helps the high energy physics experiments engaging the public interest. So the science communication is a crucial mission of our field, and I think the previous talks and the entire parallel session is a great example of that. And at CERN, we have a dedicated group of people that is works to enable thousands of visitors every year to visit our exhibitions, our older accelerators, and also the detectors of the Large Hadron Collider. However, the access to these experimental areas of these detectors is has some constraints, I listed here the constraints that we have to visit the Atlas experiment. And you can see one of example is the use of pacemaker, but we have others. And one, the most important, I would say, is of course the need to travel to Geneva to visit the detectors. And here I also show on the right side this photo and this feedback from one of the visitors of the CERN Open Days in 2019, and saying that he really wanted to visit CERN for at least 20 years. And this is a strong message. So I think we can improve the situation here, and even with the pandemic situation now. So how can we improve? We think that virtual reality allows this general public to go to the experimental areas and then have the go through the experimental caverns and explore the detectors that we have there, and even explore these inaccessible parts of the detectors, and then they can really have the feeling of the size and also the complexity of the detectors that we have. And so what do we do now in Atlas? So what we do is we bring to different outreach and social events. We use the latest technologies in virtual reality, augmented reality, and also these 360 degrees visualizations to show the people, the public, that we can travel from the control room to the experimental cavern, and then they can experience everything that we have, the infrastructures as well, and the different detectors that we have in the experimental cavern. Apart from that, we also have some interaction points that are in strategical places in the cavern that enables this photograph, this panorama at 360 degrees. And with that, we can compare the real world with the simulation that we have in this virtual representation. So moving now to the application that we have. So we have an application called Atlas Rift. And this uses a virtual reality framework developed on top of the Unreal Engine that we have here, that are part of the framework by the Epic Games. And the Atlas Rift can be used for all the VR headsets, but it's customized for the Oculus Rift. And in this application, we have 3 virtual places. So first, we have the experimental cavern. And there we have a complete representation of all the different detectors, the accesses, and also the catwalks. So the visitor can travel, can fly through the cavern, and then see everything that it wants to see. And we also have the Atlas control room, that is above the ground. And also the CERN Globe of Science and Innovation. And here it's more for the most interested visitors and there they can learn about the data taking, the physics analysis, and also the history through different tools. So concerning the hardware, before going to the images of the application, for this, we really need a laptop with a good graphics card. And this is because with the standard laptops, the 3D graphics would not be smooth enough. And then we need we really need to have a convenient frame rate in order to not get motion sickness. And this is something that we experience when we have these virtual reality headsets. And here I just added a link for the specifications for this laptop. And we also need a virtual reality headset. And as I mentioned before, the maximum immersion effect is for the Oculus Rift. And in case you don't have a VR headset, we can also download it to our laptop and use it as a standard desktop application. And there, the mouse would mimic the controller that we have with the Oculus Rift. And this is very nice. And you can also check the information to get in your computer here. In addition to that, when we are in these social and outreach events, we always have a laptop sharing in the screen the image that the people is experiencing. And that allows really a lot of people to come and be curious about what that visitor is seeing. And this is, I show here this photo that is a great example of that. Moving now to the images. So we start now entering the Atlas cavern. So this is the end cap of the Atlas detector. So we can see these mu and spectrometers, the catwalks. And this is just an example of a person that we have in different points of the cavern in order to have a feeling of the size of this magnificent detector. Besides that, the visitor can see the different subdetectors and travel from one side to the other of the cavern, also see the accesses, but a guided tour to the detector starting on the Atlas control room and finishing on the experimental cavern is also available in 7 different languages. So this is very nice as well. Here on this slide, I show also this feature that we can see different event displays. So what you see here is, of course, we just have the magnet system here represented from the Atlas detector. So we removed all the subdetectors in order to see the event display, and you see that we can see the different tracks, and here the red cones we can see the reconstruction of the jets, and here in yellow we can see the energy depositions in the calorimeters. And I really always like to show this picture because then we can compare with this old and famous photo during the Atlas construction. And I mentioned that we have this possibility of removing subdetectors or including subdetectors, and this is possible with this menu that it's with the visitor during all the experience in the virtual reality. So we can select the 3 different spaces virtual spaces that we have, and then the different detectors, and we can control what we see. Moving now up, 100 meters up, we have the Atlas control room. And here we have this representation of the different desks that we have there. And here it's a good place for the people that is really interested in the detector to talk about data taking, the physics analysis. And for that, we have two different videos here that they start when we click on it with the controller. And we also have this live website visualization of the LHC page 1. So this is this website where we can see all the parameters of the LHC live. So this is also live in the application, and it's always very nice to see and to explain what we are seeing. And next is the globe, CERN Globe of Science and Innovation. And for the lucky ones that went to CERN, you know that this is a place for exhibitions and also main events of CERN. And we use it for the same purpose. So we have here what we call the history of Atlas with several virtual posters. You can see one here examples of that. So it started in 1984, and this is just one of the last ones that it was from 2017. We also have some videos. We have a couple of videos, a total of 8 videos, and actually half of them are with sign language in order to include also people that only is with sign language. And we also have the miniatures of the detectors, and then the people can see the details that they cannot see in the cover. So this is the 3 virtual spaces that we have, and we also in our events we also have the help of the Oculus Go, and this is a standalone version of the Oculus Rift. And in this, we show the 360 degrees visualizations of the detector. And these panoramas are taken in very strategic points of the Atlas cavern, and always where the general public is not allowed to go. So this is really nice. We can see from the different floors the image of the detector. And this is really useful because being a standalone device, the people that are in the queue, they can have an idea what they will see in the next minutes. So it's always nice. Concerning the events that we already went, so this is this first version of the software in 2015. We participate in several events, and this is just a selection of them. And you can see that we had some on the United States of America, some at CERN, one at the ICHEP conference in 2018, and then 2 others on Germany and Portugal. And the last ones, they were possible because people from Atlas with the institutes with the VR headsets, they use it in the institute public events as well. And of course, besides that, the communication with the other high energy physics experiments using virtual reality is always very, very fruitful. Concerning the participation and feedback, for the events that we visit, we had the luck of being always one of the most crowded stands. And we see the interest from all ages. And normally the public that we have already has some scientific background or the general interest in science. So more or less they already know what CERN is and what is LHC and Atlas. And concerning the children, we also have a lot of curiosity from them, and they participate a lot, especially at events where more families are around. And last, we also had some for the events that we we had at CERN, it's really nice to see that we had occasions where even the Atlas members, they saw, they had this first notion of the size of their own detector for the first time. So this is what was also nice to see. In general, the people really like to travel alone, flying from one side to the other of the cavern and discover by themselves the different components of the Atlas detector. Moving now to the future improvements and also this pandemic situation. So first, we would like to include the addition of sounds during this virtual reality visit. So because when we go with the public to the Atlas cavern, we know that the ventilation, the racks, the need to the guide to speak a bit louder, it's part of the experience. So we could also add it to this virtual space. And also we would like to improve the event display, because at the moment we don't see missing energy or muons passing the detector. So this also needs to be improved. And concerning the current pandemic situation, we know that many constraints will be in the future on large public events, and also about the use of the headsets from different people. So this is a concern that we have. However, we notice that more and more people have their own VR headsets. So this is a possibility to enjoy the Atlas Rift from their homes. And for that, we would like to add some features to facilitate the self-learning of the visitor. And also, if possible, to have online public events where this community can be guided through the application and the different features that we have there by a physicist, and then they could have question and answers and so on. So this brings me to my conclusion. So I hope I convince you that the virtual reality is a great opportunity to engage, to have these different kind of outreach events. I hope as well that the difficulties in visiting the experimental areas and also the current constraints on traveling can give a boost to these activities. And I'm glad to say that the past feedback that we had is always positive, and this is only possible by the work of the people that did this real representation of the Atlas detector. And we are taking care of further improvements to enrich the experience. And we hope to be in future outreach and social events soon. Thanks a lot.
Thank you, Anna.
I keep missing my unmute button. Sorry about that. Thank you. Yeah, thank you very much, Anna. Obrigado. I had I'm missing getting the video up here. Sorry. There we go. I think it's incredible what exists now. This is a real opportunity between virtual visits and virtual reality for us to reach a really broad audience everywhere. I really like the fact that, in spite of the fact that it's virtual reality that requires having a mask, and that sort of makes a pretty strong cut on populations, that it's available on a screen, that you can do pretty much any of this using a mouse and a laptop if you want, right? So that's really, really important, because then we can reach people everywhere, and people who have limited means to have things like that. What I was curious about is the size of the team that's working on this. How big are you?
So at the moment we have I will go to my first Ricardo and Ilija are the main developers of the application. Then we have Claire that helps a lot with events, and Connie as well. And we heard some weeks ago that we will have a team that won a grant in US to really develop improve the Atlas Rift. I don't know the size of the team, but it is a group for sure. So
that's great.
Yeah,
that's fantastic. But you'll be at the Big Bang stage with this?
I don't think so. I'm not.
It's kind of hard to show this on Zoom, but yeah. we should offer some publicity for people on these opportunities. If it's possible, we'll get a good sized public coming to the different events. So you might bug Connie to say a few words, or whoever's going to be talking on the Big Bang stage to give publicity for these different opportunities. Maybe we should think of a way to advertise. I think it's the one thing our field is really missing. Is we have people everywhere. We have a lot of amazing tools, a lot of amazing opportunities, but we don't necessarily always reach out as far as we can. We need to try to publicize more. Having networks is key to that, and we can do that through our existing networks. But we need to work harder. Everyone should have this at home, in my opinion. I'm a little biased, but in my opinion, everyone should have this. Okay, so I've hogged the microphone again. Who has questions for Anna?
Can I just raised my hand, but looks like...
Yeah, go ahead. We'll do Lasha and then Pedro.
Yeah, who's first?
Oh, I didn't see us. Both hands come up.
No, I'll be last.
Okay.
Okay, thank you very much for this presentation. It's very nice approach and very, very nice application. I have two questions. The first question is about the how widely accessible is your application? Because we see here you are using the Oculus hardware. You mentioned that you need a very powerful laptop, and there are so all these things are just very highly limited the users community. So what is the strategy? So you are going to prepare just a couple of working stations from where the people can come and go to the virtual visits, or in a strategical view, you are going to simplify, to change the platforms, change the approach, and to make your application more widely accessible, not to require the very expensive hardwares, and to be workable on the cheap computers, the portable computers, or whatever portable headsets, something like the Google cards, let me tell you, which is cost the €5 or whatever. So this is the first question. And another question, second question is about the virtual reality technology itself, because it's a little bit old technology. And right now there are more modern and advanced technology, like you have mentioned. Somewhere I have seen in the title about the mixed reality, augmented reality. But however, I cannot see any other notification in your presentation about these technologies. Are you going, so my question is, are you going to little bit influence the modern approach rather than the standard old virtual reality, like the mixed reality and augmented reality? Thank you.
Thanks a lot, Lasha. So for taking into account the first question, I think the strategy would be to require less this computing side. But however, I should say that when I say that this is a computer with a very good graphics, this is what a computer is called, like a gaming computer and so on. And actually, I think during the last years, this is improving. But of course, the goal in order to spread the message in the of this application, I think, would be to not require a lot from this graphics card. Concerning the second question, for now we are just focusing on the virtual reality and not mixed reality. So we, as I said before, we would like to add these event displays, complete event displays, and also the sound. But of course, this is, as I mentioned before, we just are aware of this grant now for this tool. So I hope maybe this can change in the future, because these people that will enter to the team would be experts on this. And this is the possible answer that I have.
Sorry for a short interruption, but some TV can go 3D, no? Some televisions can display so. 3D. So you can go to Xbox or something.
Yes, actually, this was one of the main advantages of using the Epic games, because then it could be used at Xbox, and this was taken into account when we first started in 2015.
And Pedro.
I think Rebecca was before me. Rebecca Suarez. And also Meirin Evans.
Hand.
Hey, yeah, I was. Thank you for that.
Oh, there's Meirin. Okay, sorry. Go ahead.
Actually, it relates to this, so I'm going to be very brief. So the first thing, Anna, is there was really nice talk and a very nice presentation, and it's a really cool job that you're doing in here. And I was interested in trying to run this in Uppsala like a few months ago, but I couldn't get my hands in a headset. And one thing that I realized is that this is only for Windows. And going to the documentation, it says that the software is only for Windows. And there is some kind of link saying that maybe somebody can contribute to open this a little bit to other operative systems, because it tends to, like, most of us have Macs or Linux, so it becomes extra hard. So do you have any information on if anybody is interested in porting this somewhere or making some kind of virtual machine that we could connect to from different operative systems? I don't know. How is that going?
We are aware of this, and also for the developers, they need to go to Windows to add all these features. But what we would like to do is, we would like to have this on other systems, and maybe the virtual reality virtual machine would be a good idea. I hope we will have news soon about this, and for sure this is something that we are taking into account. Yeah.
Thank you very much, Anna. That was great.
Let's turn. I thought that people raising hands would get raised up to the top, but that's not the case. So I see Meirin has his hand up.
Hi, Anna. Thanks for the nice presentation.
Thanks.
I'm not surprised to hear that your stand is often one of the most popular at events. But having said that, only 2 people can be fully engaged, really, with an Oculus Rift and an Oculus Go. So how do you decide how long each person gets, where to put them in the reality? Because I imagine not everyone reads every single poster. And how do you keep the others engaged, and any other considerations for actually, running it?
That's a good point, because we always have this queue, because at least 5 minutes, I think it's needed to have a good experience. And what we do at one of the last events is to have 3 people, and then 3 people managing the visitors. And then I think one good example is this last one where we have this kid here with the standalone, so with the Oculus Go, and then the main visitor is with the controller and the headset, and then we always have these people just looking at the screen, and this is our strategy at the moment. And of course, we always try to make conversation, ask if they know what Atlas is, and trying to introduce the team at least. And this is what we are doing. Of course, the experience will bring new techniques, I think.
All right, thank you.
Thanks.
Okay, I think I've been through all the hands except for Pedro now.
Okay, so I'll be very brief. Anna, do you have an estimate of the total cost of the Oculus Rift?
Yeah, so this is also to answer Lasha about the cost of this computer. A laptop would be around 1,500 euros, and the Oculus Rift it's about 500 or 500 euros. So in total would be 2,000 euros.
Okay, thank you.
Thanks.
And the software is fully free to download.
Yes, the software is fully free. Yes.
Because we had some trouble to get certain videos to our classes in Fest 2. So I'm surprised. Thanks.
Yeah.
I was just about to thank you again, but then I had another question. And that's simply this is how far are we from making this into a game?
Yes, I don't know.
Well, I think it started as a game. It's not how far you go, it started. That's why they use gaming equipment.
Yeah, this would be really nice, but it's not on the plans right now. But it would be really nice.
Because if you want my 17-year-old son who's up there somewhere, permanently attached to a mouse, to get involved, he needs to be able to go there and play a game against other people who are already logged on to that in the same space. Just a thought. He'll be too old when it comes out, but just a thought.
Thanks.
Okay. I know that's hard to do.
Well, if I may contribute, it could be chasing particles.
Sure.
Imagine chasing a neutrino.
And anything.
Like Pokemon Go, where you have to go find things at different sites around the virtual space.
You can hide Pokemons there. It's okay. You can do anything that draws you into it and makes it competitive and accidentally teaches you some things. Would be great. Anyway, I think Anna's got already her team's got a lot on their plate at the moment. So,
yeah, but the ideas are always great to hear. And of course, that would be really great. But I'm not sure if it's feasible at the moment.
Sure.
We can talk later.
Yeah. We can do this. Can be a topic for discussion afterwards, after the next two talks, so we can save this. Okay, so thank you again, Anna. We should move on. We have a talk on mixed reality is the next one, and it's going to be Mariam, who's joining us from Georgia.
Yes, I'm joining you from Georgia. Can I share my screen?
Absolutely, go ahead.
Thank you. You can see my presentation, right?
Perfect, yeah.
Hello, so I'm Mariam Pirtskhalava from Georgia and Georgian Technical University, and I represent Georgian group, Nuclear Engineering Center. So I want today to present to you the development of mixed reality software applications for the Atlas experiment. Let me start. So it's known that a large part of information is received by human through vision. So it's also known that it's easier for a person to gain knowledge and to get to know news through vision. So that's why, along with other technologies that we heard, maybe there is an urgency to develop technologies that will help to involve wider masses into science and technological innovations. So one of these technologies can be and are visualization technologies, which convert information into a format that is easily understood and recognizable for a non-scientific person. And such visual aids shape important trends such as augmented and mixed reality that is pretty innovative. And with augmented reality, virtual content can be used in the real world, as you can see in the video. And mixed reality technology synthesizes augmented reality and virtual environment and creates a new environment where physical and virtual objects can coexist and can be interacted in real life. Let me talk a little bit about outreach. So wider masses include students and pupils who are potential software developers and scientists and innovators that need to be involved in science and technology world. So thinking about their future and possibilities of these next generations gives me and us an opportunity to say that in addition to the scientific mission, the scientific organizations also have an educational mission to awaken in young people love and interest towards scientific activities, physics and technology. So CERN's outreach knows the importance of educational mission, as we already know, and hosts and arrange a huge number of activities. Such activities are masterclasses and festivals and exhibitions. So here we can see some of them. This is our epoch masterclasses that provides an opportunity for high school students to discover particle physics, like Origin Collaboration, which is founded in 2018, and it supports events, exhibitions, and workshops for art and science. And one of them is Cognitive Festival in Georgia, which was held in 2018 in Georgia and in Georgian Technical University. It was organized by Nuclear Engineering Center, Georgia, which I represent today. This group, and it was a scientific and educational event based on the CERN research and innovation technologies that included masterclasses and public speeches and exhibitions. Like it was all together for several days. Visualization tools play important roles, as I already mentioned, and it is really important to involve them in educational missions. So one of the example of mixed reality tools we can say that is Microsoft HoloLens. It has a number of possibilities, as you can see in the video, and I can tell you several of them. So one of them is wallpapering your room with web pages. Like this HoloLens can give you an opportunity to open several web pages and you can see them floating in the air in your room, or you can attach them to the walls. Another very good feature is holographic diagram that you can build, modify, and arrange holograms into entire scenes. And also a very important part is that you can share your hologram with your friends in Skype, and you can see them, their videos floating in the air, and they can see what you see. Hologram in your room, everywhere. You can share them and describe them with your friends and discuss them. Also, mixed reality breaks emotional barriers for students, and they can experience life from very new perspectives. Like HoloLens mixed reality environment can also aid visual learners who, for example, learn through experiencing some materials, and they need to experience it fully and not just to read them or memorizing them by heart. So by interacting with this content in a mixed reality, learners can comprehend and remember it more efficiently and even better than just simply to read it from book or just to memorize it. That is why it is important to implement such tools in education and outreach. And as one of the Person's Global Director Immersive Learning says, the technology can make it easy for students to work, play, learn together, no matter what their social economic background might be, where they might be, and it will be very fun for them and very informative for them. So let me tell you a little bit of the main topic of this presentation. So Nuclear Engineering Center Georgia, in collaboration with CERNs for years and years, creates innovative technologies such as augmented and mixed reality applications, especially for CERN's outreach and education. So we have several applications, and these applications are Tracer Airtable that enables to put Atlas detector on any surface, and you have the possibility to interact with it, and we will see it in detail. And also there is an application called Airbook, Tracer Airbook, that is a 3D extension of the paper printed documents, such as documents and some additional features, and Tracer AR Door, that is for navigation inside the Atlas detector and its cavern, and also Tracer Landscape that can visualize the detector in an actual size. So some of them for specific to tell you, ART, that means Airtable and Airbook, are already developed, whilst others are under development. So for developing these applications, we use Unity, that is real-time development platform. If you're interested, and you can download our applications for iOS and Android on the link below, mentioned below. You can see the link in. For Tracer ART, so Airtable, we used AR Foundation framework. That is a special framework for AR applications, but it's not that we fully used AR Foundation as it is. We made some special changes and modifications, and also made independent engine for this project called Tracer Core, that is fully built in C#. Tracer Core enables a user to scan surfaces. That was a little bit of problem in the beginning, that we found solution with Tracer Core. Enables user to detect interactions and controls that are scanning surfaces, and then putting the detector on the surface, on the scanned surface, as well as zooming detector in and out. As you can see in the video, this is our application. And here also you can see some snippets from my code in C# that is used for zooming detector and scanning the surface. And also you can see the link below. For Tracer Airbook, we have used a different engine, that is a built-in engine for Unity, that is Vuforia. The application visualizes content on the printed documents, as you can see in the video. This is actual application. Visualizes content of the printed document in 3D and can give you additional information, and you just can see the actual detector on a paper. You can also see a snippet from my code that is used for camera focus and reading the paper. And for last, I can tell you a little bit of under development applications that are Tracer Landscape and Tracer AR Door. These are very unique applications, I would say. Tracer Landscape visualizes the facilities in the actual scale. So maybe you are sitting as in the picture with your friends in a restaurant, and you just want to show them how big really Atlas detector is. So you can open our application that is accessible from Android and from iOS to show them how actual size big detector is. So also Tracer ARD is special in its own way, because while walking in the streets, you can open application and put virtual door in front of you, and you can get inside the Atlas cavern and Atlas detector, and you can organize virtual tours inside the cavern and learn the detailed detector facilities. Thanks for your attention. Waiting for your questions.
Thank you very much, Mariam. That was very, very nice. Who has questions for Mariam on Tracer? I have to admit, I was just going to tracer.web.cern.ch and playing. Are there? I saw that they're web-based. Are there apps I can download?
They are. On the link you can see all of our applications of our group. So you can see there separately AR table and ARB. And they are not web-based, but they are made from Unity, and you have to download them and install them.
Oh, okay. So I went to applicate. Well, anyway, I'll talk later about it. I went there and was playing with it right away, so that's great. So who has another question? I don't want to keep hogging all the time. There must be something similar on other experiments, no? Is there? Maybe not.
Nothing that I'm aware of at CMS, unfortunately. I'm very jealous.
But you're no longer CMS, right?
But I'm still jealous.
Okay.
I think the CMS has something similar. The Tom Macaulay, who is the big, let me say, the locomotive in this field, and who will just develop the iSpy first. We can say that we are not the first who are developing the application like that, because the Tom Macaulay and iSpy was in front of us. So it was curious that we start in parallel this development. But I know that the Tom has developed something similar, but he is very, very concentrated to the WebGL engine. So it means that all his applications are just the web-based application. But I'm not sure that Tom is right now very busy to develop the augmented reality and mixed reality application. But anyway, he did it the first, and he has some development in this subject. The rest of the community regarding the in Atlas, there is no similar developments. In the ALICE and LHCb, I'm not sure. I cannot say nothing about this. I don't know.
You know, they're really fun tools. I'm curious, we're seeing lots of different applications here that are and projects, which are all fantastic, and somehow getting word out that these are available for people to use for education and outreach is an important job, something we need to think about doing, so that because this is an educational tool which would be very valuable in the classroom, as well as just giving it to kids and seeing which ones take off with it.
Yeah, we have the nice experience. Yes, you are right, absolutely. This is the cognitive visualization application, which have the cognitive parts, first of all, and we have the some experience watching how the kids are, the teenagers are reacting on all of these. In Georgia, we have organized the 5-time the Epoch Masterclasses, the cognitive festivals of CERN, and we widely use these applications there among the teenagers, and it's really fun to see how they enjoy, because for them this is something like the 3D computer games. And they think that they're playing, and they are playing. Yeah, sure, they're playing. They don't mind what is the Atlas detector and how the coils are looks like or whatever. They don't care about this. They have some cylindrical objects which they start playing, and this is something the tricky strategy. Let me tell you, from the cognitive point of view, because step by step they start. Giving the question, and what is this cylinder? What this cylinder is doing? And then you start to explain, or you play with some facilities. This is the scientific facility, or what is the science? What kind of science? What's happened there? And you step by step going from the game, coming to the serious things. And you always catch the attentions very mobilized, and they are very concentrating, and they are really following you. If you start lecturing and just explain that you have somewhere in Z0 point where the protons are interacted with protons, and then you have the shower of the particles, you cannot catch their attention immediately. But once you start with computer games in their units, in their telephones, in their tablets, they need no installation, and they never need some special, very expensive facilities to run these games. And they start this gaming, and then step by step you are going through the serious things. We have this observation. We are not big experts in this case, but we have some observation that this is really works.
Yeah, it's interesting. I think it's a common theme we see today, that almost every one of these projects, more serious or more fun or somewhere in between, they're all a way to get the foot in the door and to spark interest and get young minds thinking. That's great. Are there other questions? I have to look down through here.
Yeah, well, there might be one.
Okay.
Actually, I will present tomorrow something not completely similar, because it's not augmented reality, but virtual reality. And I wonder if we should try to get a common project somewhere, because the task is quite huge, and I don't know.
Pierre is from CMS.
Mm-hmm. That's great. Yeah. No, I think we should. This is something we can also discuss. I think we should be able to wander around town and find atlases and CMSs and LHCBs and atlases hiding in different places. Get the Pokemon people involved. That's just, I don't want to trivialize it, but I can. There's a lot. There's huge potential for these things.
Yeah, if seriously, Steve, I think that this comment is very nice, personal for me, because I think the events like these conferences, the main purpose is to share the information and to break some walls, because the people sometimes don't know what the others are doing behind the wall. And if we share this information, yes, it will be a big achievement of this conference if some developers, some people will find out the common interests and start out with some common projects or whatever. I think it's a very interesting comment. And so this is the CMS guy who made this comment, right?
It's Pierre, yeah. Well, so I suggest that we stick around after the last talk here, and then we can have some discussion on these if you're available. But we should get through to the last talk.
I'm sharing my screen. So.
Okay, that's good.
Okay. Thank you.
And we're going to move to Meirin. It's yeah, okay. We're going to move to Meirin. Who's going to talk about something dear to my heart. Well, close to my heart. I don't know if it's dear to my heart.
Okay, good to go?
Okay, go ahead, Meirin.
Hi, I'm Meirin, and I'm very happy to be talking with you about the Atlas public website and its evolution to Drupal 8 for this conference happening here in cyberspace. This presentation has received significant input from these amazing people in the Atlas communication team, Steve, Katerina, Sasha, and Clara. I'm going to be following through the PowerPoint on here because I've got some animations and videos, but if you've got the PDF up, you'll still be able to follow through it as well. So the Atlas public website, it's a simple domain, atlas.cern. It gives public access to descriptions of the Atlas experiment, educational resources, and updates such as news, briefings, and blogs. We've been in Drupal since 2016, which replaced the original HTML site. It was originally developed in Drupal 7, and it's maintained by the Atlas communication team. I'd just quickly like to show you some statistics about the use of the Atlas public website. And in particular, these spikes corresponding to publications and events. And I'd like to emphasize this one in early 2019, where there were nearly 100,000 views in a single week. Another thing I'd like to point out is the steady growth of visitors over the 4 years the Drupal website has been in operation. Means we're now at around 30,000 views per week. So that's the general introduction to the Atlas public website, and now about its migration to Drupal 8. First, the motivation. Drupal is an open source content management system, or CMS. I'm not talking about the CMS experiment. That would get pretty confusing. I'm lucky to not be given the CMS version of this talk. So I might be talking about CMS. It was selected for its security and management of large sites. CERN supports Drupal 7 until mid-2020, and thereafter guarantees support for Drupal 8. This migration also gives us an opportunity to improve the Atlas public website, especially give it a more dynamic look and feel. But the migration also comes with some technicalities. The migration isn't automatic. It would be really nice if it were just a case of pressing a button and everything was done, but it's not. It includes a change of template language to Twig, but it gives us an opportunity to improve maintainability and simplify future migrations so that it's a little bit more like pressing a button in future. I'd like to show you some extracts from some polls or surveys that we ran. First of all, a poll of the collaboration. One question I'd like to show is, why do you visit the Atlas public website? Now, I should give a disclaimer that there are not that many responses, so it's low statistics, but we were happy with these numbers because they validated what we already thought we knew from previous polls and surveys. And what I'd like to point out from this question is that the collaboration mainly comes to the public website to find images, maybe for their outreach talks or similar, and to find educational material, to read the physics, so maybe to find ways of explaining the physics. Another question is, how would you prioritize the audiences of the Atlas public website? And what I'd like to point out here is that the collaboration expects us to serve a broad range of audiences: primary school students, secondary, university, teachers, general public, policymakers, and other scientists. Now some extracts from a poll of the public. Who they are is something we asked them. And the majority of answers were from the general public, university students, and other scientists. The statistics are a little bit better in this poll, but again, we were happy because it validated results from previous polls as well. Second question, why do you visit the Atlas public website? The majority are coming to read the latest Atlas news, to learn about Atlas, and to learn about particle physics in general. Last question, how do you access the public website? And what I'd like to point out here is that it's through a variety of means: desktop, laptop, tablet, and phone. Now I'd just like to quickly summarize the poll input. First, from the collaboration, comes to the public site for material and news, expects us to serve a broad range of audiences, would like more educational material. And regarding the public, they identify as the general public, university students, and scientists mainly. They want the latest news and to learn about Atlas and particle physics in general, and use a variety of screens to access it: desktops, laptops, phones. And the general summary of both polls is that they are statistic limited, but they match the data from our polls of 4 years ago. And they tell us that our structure of the website, description, educational material, and updates remains valid. When starting out the migration, we set out a wish list. It wasn't Christmas at the time, but we set out a wish list anyway. The first item on the list was to upgrade the infrastructure to rebuild the Atlas site in Drupal 8 using the CERN override theme instead of the Atlas theme that we originally developed. This would help reduce the specialized templates. Item number 2 on the wish list was to improve the design to follow current trends in web development and communications, make more dynamic and responsive content, as well as easy to use menus. Another thing was to improve the usability for content developers, especially an easier layout capability. Our writer keeps asking, when will Drupal update to WordPress? And the question is, hasn't anyone come up with a similar environment for Drupal? Why not? If not. And third item was to automate a little bit the large-scale migration of content. So where are we now in terms of this migration? Regarding design, we have an Atlas visual identity implemented in CERN override, which includes color palette, logo, and fonts. And I'm not talking about Comic Sans, I'm talking about Open Sans, which, by the way, Atlas used first. We have regions and blocks similar to the Drupal 7 site. We were forced to redefine the footer, but this isn't an issue. About content types, we're using the landing page as is. Others have been redefined as in Drupal 7. They're being tested and refined. And in terms of views, they're being redefined as in Drupal 7 and also being tested and refined. Here are examples of the new Atlas public website in action. We will be able to have videos on the main landing page as well as images. An example of the dynamic content we're looking for. And there'll be nice portability from desktop or laptop to. And then if a visitor were to scroll further down the page, they would be able to see the latest news and further links to discover the Atlas experiments, the detector, physics, and the collaboration. Now I'd like to show you an example of a page about the Atlas experiment. Here's the top of the page with a picture that accompanies the text to help describe it. So a picture of the Atlas detector in this case. Then scrolling further down, some more nice pictures to accompany the text and a photo gallery at the bottom to show the history of Atlas. Another example page, in this case, the detector and technology page. Some more pictures to complement the text at the top and going alongside it here. Some visual ways to represent the numbers to do with the Atlas experiment. And this migration has also given us the opportunity to develop some new content. For example, this picture of the Atlas detector in Have a Closer Look can be clicked on in the different sub-detector components to visit pages for those components. And then once again, some links at the bottom to the technology that's used in the Atlas experiment: trigger, software computing, and technology transfer. Now I'd like to show you some new examples of the updates landing page, which would include a top feature that we really want to push the public to see. So this might be a new result or talking about the conference that's ongoing at the time. Below it, some featured features. These top 3 here. So these are things that might have come just before the top feature. And then below that, articles along with their abstracts or blurbs. This is the desktop version. It would port nicely to the tablet, looking similar there, and also to the phone, looking similar there also. I talked about that we wanted to develop a new easy-to-use menu, and here it is. We've got a new sub-menu to the updates. Another new feature is the possibility to search through updates from the title, the author, or tags such as, I don't know, Higgs physics. A nice new feature is the management and authors pages, so that the visitors can get an idea of what it means to be this huge collaboration. This is the general page for the Atlas management. Both current and past management can be seen, and then individual pages can be clicked on to get picture, some key information about them, and then a description. Individual authors that have contributed to Atlas updates and blogs can also write their own pages. So here's the library of Atlas update and blog authors, and an individual's page would look something like this: their picture, description, and the articles to which they've contributed below. Once again, a new feature are these job postings that we keep. They can be searched through and click on this plus sign to expand and find more information to get the key aspects and further links. And this will also be possible on the phone version. So what remains to be done in terms of development? We need to finish the resources, education, and open data landing pages. Regarding content, we need to finish the detailed layer of some physics pages. They'll still work as is, but to get more and more information, we need to keep adding this. We need to finish the mass import of virtual visits. And regarding design, we need to complete the responsive styling for different screen sizes to go from desktop to laptop to phone, and finish fine-tuning the Atlas elements that we've defined to really give it our own look and feel rather than cerns. There've been a few show slowers along the way, but no showstoppers, thankfully. So here I am at the summary. For the Atlas public website's move to Drupal 8, we're complying with the choice of Drupal 8 for upgrade. The CERN support team is very helpful. The CERN override theme provides most of the functionality we need. However, the theme, or perhaps Drupal in general, is frustrating for high-level design. Its environment is quite clunky for content providers, or also known as writers. It means having to develop code templates to implement our style. Having said this, the mass import of more than 1,000 nodes or pages has gone well. That was a sort of overall summary. I'd like to say that different experiments and collaborations have common goals or different approaches. Or as I like to say, we're on the same boat, but we're riding different waves. For example, CMS and Alice have a developer for their public website. IPOG are using a designer for their first implementation. So we all have these different approaches, but don't we all want to do the same thing? But anyway, we're very excited to welcome you to the Atlas public website soon. Thank you very much.
Okay, thank you, Meirin. Let me take a look here. I'm not going to ask questions because I'm deep inside those web pages right now. Maybe someone has a question. Are there any developers for other sites that are coming up? I know that CMS was getting close to the end game. I don't know how Alice is going. Does anybody know?
Well, I can comment on CMS if you like. So yes, we are not doing as big developments as you do. We are simply migrating to Drupal 8 without any major changes, and we will probably apply some improvements later this year. So first of all is focus to change to Drupal 8. That will soon, because Drupal 7 will soon disappear. So that's, I think the deadline is 28th or 7th of August.
Yes, I've heard that deadline. makes me very sad. I would like to do a lot more testing before we give up our Drupal 7 site. I don't know if is Despina still around, or maybe she's not. So I don't know the situation for Alice. I think LHCB, Bolik really loves his pure HTML, and they're going to stick with that. Those are the LHC sites. I don't know if there's anybody else who has any comment, or are we all LHC people here? All right. Any hands?
Yes, Pedro, please go ahead.
Yes, Pedro, go ahead.
Thank you very much for your talk, Meirin, and for all the Atlas people. Is there a date when you plan to release it? So let's put it this way. If there was no deadline, when do we would think it would be released?
So I'll try and answer sufficiently vague that nobody is angry at me, but still try to give you an answer. And so we're aiming to go into alpha testing with members of the collaboration by the end of the summer, and looking to have a public website by the end of the year.
Okay, thank you.
Yeah, I mean, it's very tricky because that of course doesn't mesh with our requirement that Drupal 7 is going to not be public after August. And so I have at least made an official request to delay that, and I don't know what's going to happen. I mean, if they absolutely refuse and we have to go forward, we'll have a website. It won't be completely tested though. It will have a lot of problems, and I really don't want to do that. You need to go through an alpha where you have your friends look at it and give you feedback, and then a beta where you have your non-friends, the general public, look at it and find all the bugs, because it's impossible to find them otherwise. So I would really, myself as the developer, like it to go until the end of the year, and we'll try for that. Let's see, anybody else? Any other questions? If not, I suggest we do another group video again. Try to capture this. We're trying to get some of these at the end of each session on request from Pedro, who's going to be summarizing everything.
Can you just give me 1 second? Sorry.
Okay. And then, yeah, who was it who had the fist up last time by accident? Was it? It was Matthias. I mean, you know, hey, I'm with you. I think that's fine. A fine way to be greeting people as well too. No, I'm gonna try. I will just take a picture. What I do know is that we are getting this all recorded, and we can take it from that. But we all need to at least smile. I'm gonna put this on, and we have fewer participants right now, but I will put it over just on just capture here. Last time it failed for me. It looks like it's gonna, no, maybe it just did it. Okay, let's all do, okay. Everybody.
Can we do a backup?
Yeah, somebody do a backup because I'm having trouble with my screen capture. Doing that plus Zoom seems to be a problem.
Okay.
So Pedro managed last time too. So, okay, let's all smile and wave. I clicked. Wait, keep it going for 2 more seconds. Yay, I think I got one. Okay. Thank you, everybody. I guess we agree. Do we have to move room, Miro, or do we stay in this one for discussion?
We have guaranteed 1 hour to have a room. So if you want to talk here,
we can
honestly, I don't know where is the coffee break room.
Well, this could be it. I mean, I think it's okay for us to just stay in the same one, no? For discussion.
So, yes.
I wanted to offer one topic because when I saw how incredible the virtual visit, whatever, reality, aren't we hitting actually the other problem, losing people because it's too much public, too viewed as easy? Do you follow? I mean, like we losing Sheldons.
Wait, you think outreach is too easy and so we're losing people?
I mean, if I would be high school student and seeing that people I don't like playing with phone and talking about Atlas, I would lose my attention.
I would say in the opposite way, we definitely don't want to be gatekeeping and being like, oh, it's really hard just so that we get the Sheldons.
Actually, there is an interesting
twist
to this.
I think there are different targets, and different targets, of course, need different tools. And the difficulty is that nowadays, youngsters, they do come earlier in age with contact